We're in.
Shall we play a game?
How about global thermonuclear war?
Hey everybody, it's me, the Shy Hat, and we're doing HackerFrogs after school today. Alright everybody, this is it's Friday, that means the weekend's coming up, so we're going to be doing one last hacking session for the week. So what are we going to be doing? We're going to be doing 3 things as per usual, and these are the 3 things we're going to be doing. So first of all, we're going to be learning coding for hacking, and by coding for hacking, I mean we're going to be learning about programming languages that we can take advantage of when we're doing hacking. When you're learning about binary hacking, for instance, a lot of those challenges that you get at the beginner level are written in the C language. So what we're going to be doing is we're going to be going over to Codecademy, and we're going to be doing a free course over there, which teaches us about C. So we've been doing a few of these different ones. K-Mark, hello, nice to see you here in the stream, and welcome. So the first hour or so is going to be doing some C language, learning about some programming. I know some people get into cybersecurity and they think that they don't want to do coding. They don't want to do coding. They find it intimidating. It's really not for them. I understand. When I first got into cybersecurity, I thought that that coding was going to be very, very complicated, and I thought it would be too difficult. But if you sit down and you start studying coding, it starts to make a lot of sense. It's very logical, and if you really don't want to do coding, that's fine. You should know at least a little bit about it to do some of the more technical roles in cybersecurity. But yeah, we're going to be doing coding in C, learning about it. It's not going to be super intense or anything. Neem says not good at coding. That's fine. We can all get better. And especially with so people poo-poo on AI over here, but you can use AI to teach you a lot about programming. So if you want to learn about little snippets of code, you can paste them into the AI, and you can ask the AI what exactly the code is doing. If there are some functions inside the code that you don't understand what is going on with that function, you can ask about that function, and it's a very good learning tool. I wouldn't use it to substitute for everything when you're learning about coding, but it's a very good assistant, and it serves very well in that role. And when you talk to people who do coding for a living, they more than likely use some sort of AI assistant, whether that be Copilot or ChatGPT or something else. Kmark says no one's ever good at it. Well, I'm sure there are some people who are good at it, and I learned coding as part of my hacking training, and if you learn coding with the goal of learning hacking and how to compromise systems and stuff like that, it becomes a lot easier. You can read code a lot better than you can write code. It's kind of like reading and writing other languages, but you can review code without necessarily knowing how to write in that language, the coding language. But yeah, that's the first hour of today's stream. In the second hour of today's stream, what are we going to be doing? We're going to be doing some binary hacking exercises. So the Vault 1999 says, "Hey, hello, the Vault 1999. Nice to see you here. It is a bit early, but let's go ahead and do our first fun little redeem. How about a Nyan Cat? It's a blast from the past." Okay, so we're going to be covering 2 different binary hacking challenges today, and the first one is going to be Picker 4 over here, and if you want to take a look at this challenge ahead of time, I'll leave the link over here. So that's going to be challenge number 403. Here you go. Sigma, hello, nice to see you here, and welcome to the stream. And we're also going to be doing a challenge from the ROP Emporium. The ROP Emporium is another great website for learning about binary hacking. And if you're interested in learning binary hacking, it is very fun when you get into it. And we're going to be doing that in the second hour. I'll try to be explaining as best I can how the process goes, and that's going to be the second hour of the stream. In the third and fourth hours of the stream, we're going to be getting into some Windows hacking. So the Windows system that we're going to be hacking today is called Pila in Spanish, and Pila in Spanish means either pile or stack. And this coincidentally might have to do with some stack buffer overflows. So some binary hacking there as well. If you're interested in taking a look at this challenge, it's going to be located at this website over here. It's called the Hackers Labs. It's a Spanish language cybersecurity platform where you can download virtual machines and deploy them to your network. Okay, so let's go ahead and get into the first topic that we've got for today. This one's going to be a little looser, but we're going to be talking a little bit about how to do programming in the C language. So where are we? Here we go. So if you have an account over at codecademy.com, and you can make one for free, you can access this link after you've logged in, and then you can join in with us. If you want to just listen along, that's fine. I'll try to explain this stuff as best I can. I want to caveat everybody before we start. I am not the best C programmer. I learned how to read a little bit of C language to do these binary hacking challenges, but I don't do very much writing as far as code is concerned in C. But C is a very interesting language, and a lot of interesting programs and operating systems were written in C. So stuff like Linux and Unix was written in C, and I think Python was also written in C, just for your information. Let's go ahead and start. So in this lesson, we're taking a look at an introduction to loops. Loops are a vital part of any programming language, and let's just talk about these loops. And where's the scroll down? Okay. All right, so introduction to loops. A loop is a way to repeat code or a set of instructions until a specific condition is reached. For example, have you ever been looking for someone in a grocery store? You check each aisle until you find them. You naturally perform certain tasks with the repetition or iteration until a condition is met, in this case, when you finally catch that glimpse of a familiar person. That generic term, iterate, means to repeat. You'll find that, just like in real life, you'll use loops in your code all the time. And just like this infinite... here's an interesting thing. Do you pronounce it GIF or do you pronounce it GIF? I think I usually pronounce this word GIF, but if you pronounce it differently, let us know in chat. So of blocks turning, a task may repeat something seemingly infinitely, but you always have a way to control when it stops. So when we see that a process has to be repeated multiple times in a row, we write a loop. Loops allow us to create efficient code that automates processes to make scalable, manageable programs. In this lesson, we'll learn about 3 types of loops: while loops, do-while loops, and for loops. Okay, so we just need to move on from here. And let's talk about this first little part over here. It's called interacting with a loop. So before we dive deep into the syntax of a loop, let's do a demo. We have a program that asks and checks for a PIN. So personal identification number, or PIN stands for something. It is the code that you punch in when you want to get access to something. Anyways, it uses a while loop, which will be the first type of loop that we're going to learn about. To ask the user to type and enter a PIN over and over again until the correct one is entered. As a reminder, here's how to compile and execute your code. So they've got our GCC compiler program that we can use to compile the C code. So not every exercise inside of Codecademy is going to ask you to compile your code, but some of them do. So you're going to have to use the GCC program to do that inside of the console over here on the right-hand side. You don't need to understand the code yet, just how to interact with it. Okay, so it says, step 1, compile and execute in the terminal using gcc enter pin.c and then run the program /a.out. So this first command over here is going to compile the C code into an actual program. So we can do that over here on the right. GCC enter underscore pin.c. Give that command, and then you do ./a.out. So if we take a look in the directory here, we've got two files in here. We've got the C source code file, enterpin.c, and we've got the file that we just compiled called a.out. So this is the actual program that we're going to be running here. So we're just going to do / to refer to the current directory, .a.out, and then this is going to run the code inside of this source code file. So the main function over here is going to initialize two different variables. So an integer called pin and an integer called tries. They're both set to the number 0. It's going to print bank of Codecademy just like it does over here. It's going to print enter your pin like it does over here, and then it's going to use the scanf function to get user input. So the user input we're going to put in is going to be a number. So the string format over here is for a number, which is %d. %d stands for number. I'm not too sure what d stands for, but it means an integer basically. And it's going to save out whatever we put in the code in this prompt over here to the pin variable, and then it's going to iterate the tries variable by 1, which means tries goes from the number 0 to the number 1. And then we go into our while loop over here. The while loop is Kmark. Hey, nice. Thank you very much for the emote. Thank you very much. Okay, so while the pin is not the number 1, 2, 3, 4, and the number of tries is under 3, then we're going to do this loop over here. So the loop is printf, enter your pin, and then it's going to record the pin again. So basically, the first time we enter the pin is outside of the loop, and the second and third times we enter the pin are inside this loop over here. And each time it happens, it's going to iterate the variable over here, tries, by 1, until tries is 3. And when 3 happens, then something is going to, well, it's going to exit. I think that's what it's going to do. And then it's going to check for a condition over here. Oh, I keep on misclicking this. Okay, so it's going to check for the condition pin is equal to 1, 2, 3, 4, and if that's the case, then printf pin accepted, you now have access. Okay, so let's go ahead and test out this program. So the pin, let's do 1, 2, 3, 4, 5. Okay, Ryan, hello, nice to see you here on LinkedIn. And it was nice seeing you at the cybersecurity meetup yesterday. So if you have an opportunity to meet up with cybersecurity professionals in person, please do so. It's your best way to get into cybersecurity, meet the people who are working in cybersecurity, as well as the people who are trying to get into cybersecurity, and become friends with them. Do some social networking. But nice to see you here, Ryan. Ryan was one of the many people I saw at the cybersecurity meetup. And welcome. We're just doing some C programming over here. Okay, so into your pin, we're going to avoid putting in the first. So let's see what happens if we just put in the wrong pin over and over again. So if you don't put in the right pin, then it exits you out of the program. But let's run the program one more time. So this time we're going to put in the right pin, and the right pin, as we can see from the code, is 1, 2, 3, 4. So just do 1, 2, 3, 4, and then it says pin accepted, you now have access. So we saw the while loop in action over here. Ryan says, "Thank you for advice." If I gave you some good advice, then you're welcome. I don't know if I gave any good advice while I was talking, but yeah, thank you very much, and it was very nice meeting you. Okay, let's move on to the next. Let's move on to the next little section over here. So then in the next section, we're going to do guess the number. So now that you've interacted with the loop, let's write one. So the while loop looks very similar to an if statement. And just like an if statement, it executes the code inside of it if the conditions are true. The difference, however, is that a while loop will continue to execute the code inside of it over and over again as long as the condition is true. So here's a simple form of what the while loop looks like. So we've got the keyword while, and then inside the parentheses, we've got the condition for the loop to run. And then we've got some squiggly brackets over here. And inside the squiggly brackets are the instructions that are going to run while the loop is active. Okay, so in other words, instead of executing if something is true, it executes while that thing is true. We've got a little code block over here. It says, while guess is not equal to 8, then it's going to print f, wrong try, wrong guess, try again. And then it's going to take in the user input, and it's going to save the user input to the guess variable. Okay, so in this program, the program will keep asking the user to input a new number while guess is not equal to 8. It will exit the while loop once the user types in the number 8, allowing the condition to finally become false and let the program continue. Okay, so in the instructions here it says, the checkbox will be red until you input the number 8. We have a program that asks the user to guess a number between 1 and 10. The answer we're looking for is the number 8. Run the program a couple of times and try guessing wrong numbers first. Then guess the correct number to get a feel for how the program repeats itself. As a reminder, here's how to compile and execute your code. Okay, so what we need to do here is we need to compile the program first before we can run it. So let's go ahead and do that. So over here on the right, we're going to do the gcc command on guess.c. So this is the compiler program that's going to create an actual executable program out of this source code that's in guess.c. So once we do that, we'll see that we have this file in here called a.out, which we can run with this command over here, /a.out. Okay, and then the program executes. I'm thinking of a number in the range 1 to 10. Try to guess it. So if we read the main function over here, this is exactly what the program is doing. Let's take a look. So integer guess, integer tries equals 0. And then it prints the message with the printf function here. I'm thinking of a number in the range 1 to 10. Try to guess it. And then it does scanf to get user input. So the user input is going to be saved to a variable called guess. Okay, so it says write a while loop here. So while guess is not equal to 8 and tries is less than 50, printf wrong guess, try again, and then it tries to get your user input one more time, and then it saves it to guess. And lastly, it iterates the tries variable by 1. So remember that the maximum number of tries in this case is 50 tries. And it's going to continue doing this while loop as long as your guess is not equal to the number 8. So let's see what happens if you guess the number 8. So if guess is equal to 8, then printf, you got it, and then it exits the program. So let's go ahead and try this. So we're going to try to guess the number. We're going to try 1, wrong guess, try again, 2, 3, 4, 5, 6, 7. And then when we try the number 8, it says you got it, just like it says over here, and then it exits the program. Okay. So the second step says, now instead of just asking the user once, let's add a while loop to handle the repetition of guesses. To limit the loop, we'll allow up to 50 tries. Okay, so, after adding the loop, compile and execute your code using this. Didn't we just do this? Hold on, let me reset the workspace just in case. Okay, okay, so it looks like it took my code from before, and yeah, I've done this one already. Let's go ahead and write that while loop one more time. Where are we? Okay, so first of all, we need to compile the program one more time. Let's see. So it's going to be gcc guess.c, and then run a.out, and then we'll guess 8. Okay. So the second step is Let's add a while loop to handle the repetition of guesses to limit the loop we've allowed up to 50 tries. So I think what they want us to do is they want us to just copy and paste this loop into, actually, we won't copy and paste. We will copy it, but let's understand what's going on here. So we start with the keyword while, and then between the brackets, we've got the condition that has to be true for the while loop. And then let's go ahead and put in our brackets. We need some squiggly brackets here. And between the squiggly brackets, we're going to write our instructions. So the while condition in this case is going to be between the parentheses. So it's going to be guess not equal to 8 and tries less than 50. Okay, so just like this. And what we're going to do is we're going to put our code between the curly braces here. So the curly braces, let's go ahead and write our code and print f wrong guess try again. So I'm not gonna type all that out. I'm just going to copy and paste. Remember everybody, copy and paste is your friend when you're doing programming, when you're doing anything basically, and you're interacting with a computer. Anyways, okay, so it says print f wrong guess try again, and then that's the first instruction. The second instruction is to try to get another guess from the user with the scanf function over here. And it's going to save it to guess. The last thing it's going to do is it's going to iterate and increase the tries variable by 1. Okay, so let's go ahead and I think what we need to do is okay. So after this is done, it's going to break out and it's going to run this code over here. If guess is equal to 8, then we're going to print f, you got it. So let's go ahead and try this out. So we're going to do one more time, gcc guess.c, and we're going to run a.out again. Okay, so we're going to guess 1, 2, 3, 4, 5, 6, 7, and then when we guess 8, then it says we got it, and then it exits the program. Okay, let's go ahead and move on to the next section. I'm going to reset this workspace just in case I put some stuff in there before. Anyways, so for the last loop, we held your hand, so let's try this one on your own. As an example of iteration, we have the first program ever to run on a stored program computer, the EDSAC. It was written and run in the computer laboratory at Cambridge University, England, on May 6, 1949, to calculate and print a simple list of squares like the following. So we've got the number and its square over here. So 0, 1, 1, 1, 2, 4, 3, 9. So it's basically the number multiplied by itself. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, etc., etc. So on the left, there are the numbers 0 to 9, and on the right are their squares. For example, for the number 9, it's 9 times 9 equals 81. So note, an algorithm like this is one of the easiest tells for needing a loop. But as you develop your programming skills, you'll pick up more and more subtle hints and uses for where loops can be incorporated into your code. Okay, so let's go ahead and read the instructions. So number 1, write a while loop that prints out a number followed by a tab, then the square of that number followed by a new line, like so. Okay, so they've kind of written it for us, not exactly for us, but let's go ahead and copy this code here. So have the while loop calculate this from 0 to 9. Note if you notice the run button spinning continuously or a lost connection to Codecademy message, in this exercise, you may have an infinite loop. If the stop condition for our loop is never met, we will create a loop that never exits, which prevents the program from ever completing. In this exercise, you can simply refresh the page to stop the infinite loop, then fix the code for your loop. However, we'll talk more about infinite loops later and how to use them effectively. Okay, so we've got the little snippet of code that we just copied here. We're going to use it to write our loop. So, you know what? We're going to be pasting this in just a little bit. We're going to write our while loop. So while condition in the parentheses and the square brackets, just like this. So while, let's see. So I is less than, let's say I is less than 10, because we want the number to go up to the number 9. So it has to be less than 10 in this point at this in this code. So while I is less than 10, then do something. So the something is going to be this printf function over here. So printf number and then tab and then number. Okay, so number times number. So in this case, we're not taking a look. We're not doing number. We're going to do the first number is going to be the integer variable, and the second number is going to be square. So square times square. Okay. Square times square, and let's see, what else do we need to do inside the while loop? Inside the while loop, we also need to iterate these numbers. So we're going to iterate the I variable, and we're also going to iterate the square variable. So I plus plus and square plus plus to add 1 to these numbers each time the loop runs. Just a second. Okay. So I think that's all we need to do for this code. Let's go ahead and run the code and see what happens. So if we coded this correctly, then we should get output that looks like this. Let's go ahead and run the code. Okay, and this is exactly what we're supposed to be doing. Great. And let's see if there's any other things we need to do before we move on. Okay, so it says now change your while loop to go backwards from 9 and stop at 0. Your new output should look like this. So we're basically doing the reverse of what we just did. We're going to be counting down instead of counting up. Okay, we got ads on Twitch. When with our ads on Twitch, we also do ads on YouTube. Let's play an ad on YouTube, and let's put on some fabulous birds. I love my birds, and I've got a little bird feeder outside, and I film them having lots of fun eating stuff at the bird feeder. Let's go ahead and watch one of these videos that features the beautiful birds. Okay, so I'm going to take a little water break while the ads are running. We'll be back in just about a minute. Hold on, everybody. We're just taking a little ad break right here because I'm live streaming on Twitch and YouTube, and on Twitch we need to to do ads every once in a while. When the ads show up, we stop the action and we take a little break. It's also a good opportunity for me to have a little bit of water, because when you talk for 5 hours nonstop, you need some water to to keep your voice going. Anyways, let's go ahead and put the birds away, and we'll have more birds when the next break happens in about half an hour or so. Okay, so what do we need to do? We need to adjust the code so it does this output instead of this output. So what do we need to do? So we just need to adjust the code like this. So the integer is going to start at the number 9. So I is going to start at 9, and square is also going to start at 9. The next thing we need to do is we need to set up the while loop differently. So while I is greater than -1. So while I is greater than -1. Because when we reach -1, we have to stop, which means that the last thing that's going to be iterated is the number 0. and we need the number 0 in our output, as we see over here. Okay, so we're going to do the same thing. The printf statement is going to stay the same, except that we're going to, let's see, decrement instead of increment with the minus minus symbol instead of the plus plus symbol. So if we do our code like this, then we should be able to get output that looks like this from the while loop. Let's go ahead and run the code and see what happens. Okay, so it looks like it worked. So we started with 9 times 9, and then we went to 8 times 8, 7 times 7, 6 times 6, etc., etc. And then when the I integer became the number -1, then the while loop became false, and we broke out of it. Okay, let's go ahead and move on to the next part. Okay, so this is going to be the do while loop. So now that we've written a while loop, let's write an alternative form of it. We'll look at the syntax first and then explain what's happening and why. So we've got in here, do something while something. So what is this type of loop over here? So this is odd. The condition came after the statements. Does this mean the condition isn't checked until after the statements get executed? So the answer is, that's exactly what happens. So this is what is known as a do while loop. Simply put, it does something first and then checks the condition afterwards and loops in this manner until the condition is no longer true. The do while loop is most often used when a program wants to do something at least once before checking the condition. Okay, so the instructions here are convert the while loop into a do while loop. Okay, so the while loop over here is, what is it? It's integer equals 11, do, printf the number, and then iterate the number up, and then while, okay, hold on. This is another case, well, where I forgot to reset my progress, so the exercise is already done. Anyways, okay, so what is this? So integer equals 0. Okay, so we've got integer I that equals 0. While I is less than 10, print the number and then increase it. Okay, so what do we need to do here? So the format for the do while loop is this: do something something while something something. So we're going to do, let's just cut this out here. So do inside the squiggly brackets, and then after the squiggly brackets, we're going to do while, and then inside the parentheses here, let's paste in the code that we cut out. So while I is less than 10. So this should achieve the same thing. So it's going to do this first, and then it's going to check whether or not we need to break out of the loop. And so the do while loop means that we're going to do something at least once, and then we're going to check whether or not it needs to be done again. Anyways, let's go ahead and run the loop. And looks like we forgot to do something. Expected declaration or statement at the end of the input here. Do I have an extra? I've got an extra parentheses here. So if you make sure that you have the right number of parentheses. If you have too many or too few, that's a big problem, especially when you're dealing with something as precise as writing code. Okay, let's run it again. Did you set I to equal 11? Oh, but let's see. Main function, do something. So these two brackets match, these two brackets match. Do something while something. I forgot to do the this. So at the end of the while instruction here, we need to put a semicolon. So I'm too used to writing code in Python where you don't use semicolons. Anyways, let's run this. Okay, so this counts up. And the next thing we need to do is we need to do the second step. So the second step here, you may have noticed there wasn't a difference between the outputs of this particular while loop and the do while loop. So to see exactly how they run differently, change int I equals 0 to int I equals 11. Run it again. What do you think will happen? Okay, so we're just going to go and adjust the I variable to 11. So here's the thing. The while condition here is while I is less than 10, but we've already set it to something that is over 10, which means that the while condition is false. What do you think is going to happen when we run this code? So is nothing going to happen? Is it going to run once, or is it going to run multiple times? What do you think? So due to the nature of the do while loop, it's going to run this code at least once. And then it's going to check for the condition. Let's see, Sick in the Mind says probably skip the loop. So the do while loop is always going to run once. That's the nature of the do while loop. So if we run the code, we get the number 11. So it did do the thing once. And then after it did the thing once, then it checks. Yeah, we're using C right now, yeah. But Sick in the Mind, welcome to the stream. Nice to see you here. Kmark says it will print once and then end the loop. Yeah, so this is what they're trying to teach us in this particular part over here. The difference between a while loop and a do while loop inside of C. Good evening. Hello, nice to see you here. All right, let's move on to the next section. Okay, so this is the more, as far as syntax is concerned, this is the more complicated loop inside of C. So the while loop example we looked at so far, iterate over the sequence of numbers. This is so common in C, like many other programming languages, it has a special syntax for this. When we know exactly how many times we want to iterate or count, we can use a for loop instead of a while loop. So for example, this is a for loop. So the syntax for the for loop is a little more complicated, but in the long run, there's less. It does make sense if you take a look at it. So for, and then they initialize the integer that we're going to be iterating over inside of the conditions over here. So integer I equals to 0, and then we stop. The next thing we do is we set up the stopping condition. So I is less than 10, which means it's going to keep on looping until I is less than 10. And the last thing it does is it's going to set up what happens at the end of each loop, which is to increment the I variable by 1. So that's the instruction here. And each time the loop runs, it's just going to print out the I variable over here. Okay. So let's take a look at the first line. This is the line here. There are 3 parts to this separated by 2 semicolons. The initialization of the counter, which is int I equals 0. We've got the condition, I is less than 10 over here. And the change in the counter, in this case, in increment, which is I++. So in the first part, we create the variable I that starts at 0 and acts as our counter. In the second part, as long as our counter I is less than 10, the statements within the loop will repeatedly run. In the third and final part, after each iteration of the for loop, we add 1 to I using the increment operator. Or in other words, we start with some initialized variable, then while some condition is true, we do something, then we incrementally change the control variable. Does this sound familiar? So it's just like a while loop. In fact, the above for loop does the exact same thing as the while loop we just worked with in the previous exercise. So this while loop from exercise 5, this one over here, so this is just like the loop that we see over here, but it's actually going to be a lot shorter as far as the code is concerned. Okay, so this distinction is important because it allows us to switch between while loops and for loops to best fit the current program's needs. if we don't quite know when a loop may end, we use a while loop. If we do know exactly when a loop should end, we use a for loop. Okay, so let me reset the environment here. The instructions, number 1. First, let's start with what you already know. Write a while loop that starts at 99, stops at 0, and prints the following. So I, bottle of pop on the wall, take one down and pass it around. I minus 1 bottles of pop on the wall. It should then decrement I by 1. Okay, so what are we doing here? We're running the while loop. We need to this is a little song that we sing. 99 bottles of pop on the wall. 99 bottles of pop. Take one down and pass it around. 98 bottles of pop on the wall. Okay, like this. So let's go ahead and write the while loop. So while condition and then curly braces. So while condition curly braces, while I is, what is it? Stops at 0. So while I is not equal to 0, stops at 0. Actually, it stops at 0, so it should include 0. So while I is not equal to -1, we could try this one. Or we could say while I is not less than or equal to -1. Or wait, while I is greater than or equal to -1. No, while I is greater than -1. Anyways, let's do it like this. Okay, so we're gonna print something. So we're gonna printf, and we're gonna do 3 printf statements. So I might as well just copy these. So printf, and we're going to print out these lines from the song. So let's see. Bottles of pop on the wall. Let's copy this and paste it in here. And the last line over here. Oh, okay. Man, anyways, don't misclick, don't miss punch in anything on the keyboard. Okay, so for each time we refer to I, we're gonna have to use the string format. So the string format for decimal numbers, sorry, not for decimal numbers, for integer numbers is %d. So we're just gonna do %d for these lines over here, %d, and this is gonna be, what is it? This is going to be I, and for the last line, it's going to be I minus 1. Okay, so print all this stuff over here, and on the last line, we have to increment the I variable. So the last line is going to be I plus plus. Okay, so I think this should run. Let's go ahead and run the code. It looks like I did an infinite loop. Okay, hold on. What is, okay, if you all can spot what's wrong with the code, let me know. Actually, I think I had this exact problem last time. Okay, so I wrote the while loop. It starts at 99, stops at 0, prints this. It should decrement. Oh, sorry, I did increment. That's my problem. So it has to be decrement. Anyways, let's reload the page. First of all, I'm just gonna copy my code over here just in case it disappears. We're gonna reload the page. Okay, it looks like the code is the same. Let's go ahead and run the code. Okay, so let's see. Oh, you know what? It stopped with -1. I should stop it at 0. You know this is correct. It should be 0. That should be the last one. Okay, so the next thing we need to do is we need to do the same thing but with the for loop. So let's go down here. Convert your while loop into a for loop. So most of the stuff inside of our loop is going to be the same if we're using a for loop instead of a while loop. The only thing that changes here is that we need to declare the iterator variable inside of the while loop. Sorry, inside of the for loop. So let's get rid of this. And then let's rewrite this. So what does the for loop look like again? It's always about the syntax. So for something something over here. Okay, great. So it's going to be for, and then integer I equals 0, semicolon, and then I is going to be less than 0. Okay. And then the last thing we need to do is we need to decrement I like this. So this is going to do the same thing as the while loop. Instead, we're using a for loop. We need to initialize I as 99, of course, and I think this will do the same thing. Yeah, it does the same thing. Okay. You know what I forgot to do? I forgot to add my line breaks over here. So let's go ahead and add these line breaks. It'll make everything look much nicer. So add the line breaks, and let's run it again. Okay, that looks nicer. Okay, let's go ahead and move on to the next section then. So breaking out. So there are a couple, just like Python, we've got two special keywords that we can use inside of loops. So that is the break keyword and the continue keyword. But they work basically the same in C programming as they do in Python programming. So when working with loops, it's important to know a few special keywords that can affect how a loop runs. Let's take a look at a quick example to introduce the first special keyword. Do you remember the while loop from exercise 3? So over here, while guess is not equal to 8 and tries is less than 50, print wrong guess, and then get another guess. The loop runs until 8 is guessed or 50 attempts have been made to guess the secret number. This means the loop will stop running as soon as one of those conditions is met. There's another way to write this, but using a special keyword. See if you can spot it. Okay, so we got this code here. While tries is less than 50, get the user input and save it to the guess variable over here. If guess is equal to 8, then break out of the loop. And so it keeps on going, but if we exceed 50 tries, then it's going to break out of the loop anyways, and it's going to print wrong guess, try again, and then increment the tries variable. Oh, okay. So it stops the program if we guess the number 8. If it's not the number 8, it doesn't break out of the loop, and it's going to print wrong guess and then increase the number of tries. Okay. So the keyword break allows us to quite literally break out of the loop and stop it from running any more times. It can often simply be avoided with careful planning of the conditional controlling a loop. It's generally advised to be careful when breaking out of loops because it can result in unexpected processing when a programmer has a mental plan centered around a loop finishing all of its iterations. However, when used effectively, a break can increase the efficiency of a program and help minimize its memory uses through unnecessary variables. So note, break is most often used when a program wants to run a loop infinitely in a controlled manner. For example, a program that runs until the user types quit. In that instance, the program may run forever, but only break out of its running loop when the user tells it to. Okay, so in our instructions here, in our program, the while loop will run a set number of times or until a non-positive number is entered. So this includes the number 0 and negative numbers. Without changing the condition of the while loop, try to get it to stop when a non-positive number is entered using the break keyword. Okay, so let's take a look at the loop over here. Let me reset the code. Okay, so we've got some integers that are being initialized over here. So number 1 and numbers entered. So I'm guessing that numbers entered is going to be iterated. And I guess number 1 is also going to be iterated from my guess. So while numbers entered 1 is less than 10, loop 1, please enter a number, and we're going to get user input from the scanf function over here, and we're going to save it to number 1. Okay, so the number 1 is whatever the user is guessing in the program. Okay, and the next section over here, figure out how to break out here. So we needed to break when a non-positive number is entered. So we're going to write our if statement. So if something, then curly braces. So the condition for the if statement here is going to be number 1. So that's the name of the variable. Number 1 is less than or equal to 0. So if number 1 is less than or equal to 0, then we're going to break out of this. So it's going to be break, and I think that's all we need to do. And then at the end of the loop over here, numbers entered is going to iterate by 1. So the while loop over here is going to keep on going as long as the number of tries that that we enter in is going to be less than 10. Let's go ahead and run this code. And I guess nothing happened. I guess that's because they want us to compile the program. Okay, so number 2, you may have noticed the break keyword isn't necessary here to stop the loop from running. Create a second while loop below the first one and use the condition. Okay, it looks like I need to ban a viewer that is spamming the chat. Anyways, let's continue. Create a second while loop before the first one, below the first one, and use the condition number 2 is less than 0 and numbers entered less than 10. Okay, so this is a way of avoiding using the break command. So in this case, we're going to write it into the condition for the while loop. So let's go ahead and do that. So let's see. So I guess what we need to do at the bottom here is we also need to iterate for our new numbers entered, and just so that people's OCD is not triggered, I'll put it here after numbers 1 is being iterated over. Okay, so what are we doing in here? So we're going to be actually we can't do it in here because we're supposed to do it inside the loop. Never mind. Let's so inside the first loop, inside the first while loop here, let's write another loop. So the other loop is going to be inside the loop. So this is a loop inside a loop. So the loop is going to be while something and then do something. So what do we need it to be? So number 2 is greater than 0. Number 2 is greater than 0 and numbers entered is greater than 10. Okay, let's copy and paste. So this is the condition for the second loop here. And we need to write our instructions. So the instructions here are going to be the same as this one over here. So printf loop 1. So instead of loop 1, it's going to be loop 2. So let's just copy paste this code and put it in our second loop. So when we do this, we need to make sure that our indentation is correct, otherwise it's going to be hard to read. Okay, so this is going to be loop 2 instead of loop 1. And we're going to save this to number 2 instead of number 1. And we need to increment the numbers entered 1. Sorry, the numbers entered 2. So let's copy this line. We'll put it at the end of the while loop. And we're going to make sure that this is numbers entered 2 instead of numbers entered 1. Okay, so let's see. Let's go ahead and run this code. Hopefully there's nothing super wrong with the syntax. I hate debugging on the live on stream, but anyways, let's run this. Did you add number 2 equals 1? Ah, okay. Let's see, number 2 equals 1. Oh, I forgot to add these over here. So we need to add these 2 variables to the top. Okay, let's go ahead and do that. So we're just going to copy both of these. We're going to paste these in, but we're going to make these numbers 2 instead of numbers 1. And I think after that, we've got all the stuff we need to run these 2 loops. Okay, so it says that it worked. The problem is that we didn't get any output from the program because they want us to compile it. So we've got infinity.c. We're just going to use DCC to compile the program. And then we're going to run the program a.out. So it says loop 1, please enter a number. And we'll just keep on entering some numbers. But we can also exit the loop by entering the number 0 or a negative number. So we're just going to enter the number 0. And let's see, we got loop 1 enter a number. Okay, so loop 1, let's break out of this one as well. And it says, good job, you've broken out. Great. All right, let's go ahead and move on to the next section. I think this is the last section before we finish the lesson. And yeah, the timing works out too, because we got about 4 minutes left in this particular section of the stream. So it says continuing. So in a video game, a game over screen often allows you to continue from a previous save or checkpoint. We've got ads running on Twitch. When we do ads on Twitch, we also run them on YouTube, and we put on some lovely birds. How about these birds right here? So please enjoy the birds while we take a little ad break. It'll be about a minute or so. I'm just going to have a little bit of water. We'll be back in just a few moments. So like I said, this is these are the lovely birds from the backyard bird feeder, and this is my favorite bird are the black and blue Steller's jays. These sparrows over here, they're fun to watch as well. But everybody sees sparrows wherever they are in the world. If you live in a world that does not have sparrows, let us know, and you will be a very exceptional person. Okay, let's go ahead and put the birds away, and we're going to finish off our lesson. Okay, so in a video game, a game over screen often allows you to continue from a previous save or checkpoint. Loops can do this in much the same way using the continue keyword, and this is the second keyword we'll be learning in this lesson. In a loop, if a continue is ever reached, it will immediately skip the rest of the statements inside the loop body and continue into the next iteration. So basically, it's going to run the instructions in the loop, but if a continue keyword is executed, then that particular iteration of the loop is going to be skipped, and then it's going to continue on into the next iteration of the loop. Okay, for example, let's take a look at the following syntax. So hold on. So in the syntax over here, it says for integer I equals 0 and I is less than 10, then increment the I variable. If I modulo 2 equals to 0, then continue. And then for every loop, we're going to printf number is odd. So this is basically a little check that checks if a number is odd. We do the modulo operation versus against 0. And if the modulo of the number is 0, then it's an even number. Otherwise, it's an odd number, and we print this message over here. Okay, so that's this is the meaning of the continue keyword over here. We do our check. If the number is even, then we don't print it. We skip this instruction over here, and we just go over to the next number. So inside the for loop, we see an if statement checking if the current counter I is an even number by using the modulo operator. If I is even, continue to the next iteration and skip the print statement below. If I is odd, print I and continue as normal. So note, these keywords can still affect a loop even if they're contained inside an if statement. This means a continue will always advance to the next iteration even if it's nested in multiple if-else statements. This goes for other loop keywords as well, like break. If there are nested loops, a keyword will only interact with the most interior loop it is contained in. Okay, so in our instructions it says, use continue to make the while loop skip the print statement for when I is equal to 5. Okay, so this is the loop over here. So the while loop is here. We want to skip the number 5. So we're just going to use an if statement to check. So we're going to check if something in the parentheses, something in the squiggly brackets. So in the parentheses here, this is going to be the check. So I is equal to 5. Then we need to do something. So the something we're going to do is continue. So continue means that we're going to skip this particular iteration if the number is equal to 5. And then print the number over here, and then increment the number. So the while loop over here is basically going to print every number except for the number 5, because when the number 5 is encountered, it's going to skip the print statement. Okay, let's see if this works. So we run the code, and I'm not sure. I encountered this in the when I did this last time. It didn't print out in this case. I don't know. I don't think I have anything wrong in my syntax over here, but for some reason it treats this as an infinite loop because it's not going. Let me just do a quick scan of the code to make sure that everything's matching up. So this matches with this matches with this. We're let's see, incrementing the I variable. While I is less than 10, this should work. I'm not too sure why it's not running. Anyways, the code did not produce the correct output in the terminal. Yeah, I don't know why this doesn't work. The code, I'm pretty sure this is correct. I was doing it this morning and I encountered the same problem. Let's go ahead and skip to, well, actually, you know what? Let's see what they actually want for this code. I'm just going to run it again. And it does the infinite loop. Let's reload the page. Because this should work. You know what? Just for fun, I'm going to pass this off to the AI and see if it can identify if there's anything faulty in this code. Just for fun, are there syntax errors or infinite loops in this code? Okay, paste in the code. Okay, it says the code contains a critical issue that will cause an infinite loop when I reaches 5. Continue skips the increment. Continues, oh, huh. When I equals 5, the continue statement jumps back to the while condition without executing the plus. Oh, I stays at 5 forever. Huh. Okay. I didn't spot that earlier. Let's go ahead and add this to the if statement. So if that's true, we just need to add I++ over here and then continue. And that should fix the infinite loop. So let's run this. Okay, now it works. Great. All right. So this is something new. I don't usually write a lot of loops using C. Okay, so convert the while loop to a for loop. This way, you don't have to worry about whether or not your counter will increment as normal when a continue is called. A for loop will naturally increment the counter for you after any given iteration is completed. Okay, so in this case, we need to get rid of the I counter, the I variable declaration over here, and we need to change this from while to for. So for int I equals to, where did it start? It started at 0. Then we do I less than 10, and we do I increment like this. Okay, so I think we also need to get rid of these increment instructions over here because they're not necessary instead of a for loop. Okay, we'll get rid of this instruction as well. And I think this should be okay. Just to make everything look a little better. So my problem with with C code is that sometimes I really want to make everything look nice and neat. Let's go ahead and try out this code. Okay, it does the same thing, so we're done. All right, so in the next section it says review. You completed the lesson on loops. So the key concepts covered in this lesson were loops. They perform repetitive actions, so we don't have to code those actions manually every time. We learned how to write while loops with a condition. We learned how to write do loops with a condition. We learned how to write for loops with a counter that decrements or increments. We learned how to break out of a loop, and we learned how to continue a loop at any point. You know, just for fun, I'm going to grab some of the code from one of these previous steps, and we're going to take a look at it inside of. So let's see. This is the code over here that basically just prints the numbers 1 to 10. I want to take a look at it inside of our debugger to see what it looks like when we look at it the disassembly. So first of all, let's go ahead and let's use the JS Linux machine. So everybody can use the JS Linux machine. Actually, wait. Everybody can use the JS Linux machine, but it doesn't have some of the programs that we like to use installed in it. Let's go ahead and use the Pico CTF web shell. So if you don't have an account over at Pico CTF, you can go ahead and make one. Let me just get the link. And Pico CTF is a very good website for learning about cybersecurity stuff. So go ahead and make an account over at picoctf.org. If you're interested in learning about cybersecurity, it's a very good website for learning about different concepts of cybersecurity and a lot of different categories. We're starting into our next section of the stream, so let me go ahead and play some. Let's play some music. Let's see. Let's try some. Let's start off with the Faster Than Light soundtrack. We usually end with it, but it's a very nice soundtrack. It's a sci-fi game with some very funky music. Okay, so as usual, if the music's too loud, let me know, and we will adjust the volume. I'm adjusting the volume down already, just so it doesn't get too loud. Okay, so let's go ahead and access the picoctf web shell. So after you've logged into picoctf, there's going to be a practice section over here. You want to access that. And then after that, you can access the picoctf web shell, which is a Linux machine, by clicking on this button over here. It's on the right-hand side of the screen. It's labeled web shell. And after you've logged into the web shell, you're going to see your username -picoctf at web shell. The problem is that this is a little bit small. We want to get a much bigger view so it's more comfortable to look at. We can do that by going over to the web shell and then clicking on this button that's beside the help button. It's labeled pop out web shell terminal. Click on that, and then hopefully the web shell is started up in its own browser tab, which would be much bigger. It looks like it's not working right now. That's fine. We can just go back, and then we can repeat the process one more time until it actually works out for us. So sometimes the picoctf servers are a bit unresponsive, but it's okay because because the people at picoctf provide the service for free, and we can't be too demanding when we're getting services for free. Okay, looks like this didn't work either. Let's try one more time. So eventually it will connect to you, and then you can click on the pop-out web shell terminal button. Okay, so when you get the full screen web shell terminal, this is what we want. Okay, what we're gonna do is, first of all, if there's anything inside the web shell terminal, we should probably clear it out, because we don't want anything to be too cluttered in here. The second thing we're going to do is we're going to copy some C code over, just so we can see what happens when we compile the program and take a look at it inside of assembly. So let's go back to Codecademy, and let's just copy all this code. We're going to go back to the web shell, and we're going to edit this inside of the nano text editor. So it's going to be nano loop.c. So we're just going to call this file loop.c. We're going to paste in our code, and this does something very, very simple. We're going to get rid of the if statement here, because we don't necessarily need to take a look at this. Let's get rid of these lines of code. I think we also need to get rid of this over here. Okay, so this is all the code we need. So for integer I equals 0 until I is less than 10, and then increment the I variable, print the number. So this should be okay code. Let's let's go ahead and save this, and then let's compile it using the GCC compiler. So we're going to do GCC, and we're going to save this as the loop program, and we're going to run this on loop.c. So after that's done, it creates the program as just loop, because we specified the out program in this case for GCC. So when we run loop, all it does is print out the number 0 to 9. Let's go ahead and see what this looks like when we take a look at it in debugger. So we're going to run Radare2 because it's our favorite debugger. And let's run it on the loop program like this. Okay, so when we run the Radare2 program, it's going to analyze the program. After that, we need to find out what the name of the main function is, which we can do by doing all functions list AFL. So there's actually a lot of functions in here, but the only one that we see at the top over here, it's going to be called main. It's just called this, main. We can take a look at what is in the main function by doing print disassembly function, so pdf at main, like this. And this is going to show us what happens inside of the loop. So we can tell that there's a loop going on because they've got these arrows over here that points at different pieces of code that are jumping around. So what is this going on? When we take a look at the assembly instructions for any C program, they're always going to start with this instruction right here, endbr64, and they're going to end with the ret instruction. So this is the start of the function, this is the end of the function. And what is happening in the middle here? We got a bunch of we got a push instruction to push whatever was on this particular what are they called? Memory register. So the RBP, the base pointer, it's going to be pushed onto the stack. Then we're going to move into the base pointer, the stack pointer over here. And then we're going to, where does it actually print? Ah, okay, it prints over here. So int printf. So this is what actually prints out the number. And then we add into the variable. So we got two variables, and the first variable is the integer. So the integer I. So that's going to be, we're going to add 1 to that variable. So this is what counts up the I integer. Sorry, the I variable. And we're going to compare against the number 9. So this is the part of the code where it terminates the loop. We do a comparison, and if the comparison is false, then we keep on running the loop over here. And when the comparison is true, so JLE is jump less than or equal to, right? So if 9 is compared and it is less than or equal to, then we jump up to this instruction over here to do, let's see, move into the EAX register the variable here, and then man, I'm getting a bit confused looking at all these instructions over here. Basically, we load into the memory registers everything we need to print out the number in these instructions over here. And I'm assuming that we break out of the loop over here, but it just brings us back to how do we eventually get to these instructions which break out of the main function? Anyways, let's go ahead and start our next portion of the stream. And in the next portion of the stream, we're going to be taking a look at some binary hacking challenges. So the two binary hacking challenges we've got lined up today are, the first one's going to be this one over here, picker4. So everybody, if you wanted to join in along with us, then you can go ahead and log into Pico CTF. You should probably start up your web shell before you access this challenge over here. And this is going to be this challenge called picker4. It's a medium level challenge in the binary hacking category. This is a Pico Gym exclusive challenge. And it says, can you figure out how this program works to get the flag? Additional details will be available after launching your challenge instance. So here's what we're going to do. We're going to click on the launch instance button over here. That's going to start up the server where we can communicate with the binary that we need to hack. But most importantly, we have to examine the files that are associated with the program. And it says that the program source code can be downloaded here and the binary can be downloaded here. So let's go ahead and, well, let's quit out of here first. And let's get rid of these files so we don't clutter our workspace. So there are two files that we need to download in this case. So the program source code can be downloaded here. Let's go ahead and copy that link. Then after that, go back to our web shell, and we're going to download the file with the wget command. So wget space, paste in the file location, and then hit enter to download the file. So if you just want to use this, use whatever command I just used, that's the command you want to paste into your terminal there. And the second file that we need to get access to is this one. Over here, wget this thing. And that's the command. Okay. So we've got our two files that we need to solve the challenge here. Except that this file over here, we need to make this file executable in order to use it. So picker-iv, so that's number 4. We're just going to use this command right here to make the file executable so that we can actually work with it. So chmod plus x, which means to give to change the mode of a file, we're going to make it executable on picker-iv. Run that command, and then afterwards you're going to see that in the terminal the file is turned green. So green inside of this terminal means that it's an executable file, and we can run the file with /picker-iv, just like this, to run the file. So it says enter the address in hex to jump to, excluding the 0x. Okay, so this is an example of what is called a return to win binary hacking challenge. So in this challenge, all we need to do is we need to know the address of the function we want to access. And since we don't know what address we want to use, we'll just put in something random. And it says segfault triggered exiting. It means that the program crashed. We can just Control C to get out of the program. And we need to examine the source code for the program to understand what is going on in this challenge. So here's the source code for the challenge, picker-iv.c. We're just going to take a look at it inside of the Nano text editor. Just like this. So nano picker-iv.c, and that's going to open up the file. So this is a C program file. So all the C code that we learned about in the previous part of the stream, it's going to look a little bit familiar, but what we need to understand here is that there are several different functions that are defined inside this code, and it's this code that was used to create the binary that we're trying to hack. So first of all, we've got this function here called print segf message. So segf stands for segfault, and segfault is basically when the program crashes because there's some unexpected stuff inside the memory. So it says, it just prints the message, segfault triggered, exiting, and then it does sleep for 15 seconds, and then it does the exit function over here. Another function inside of the source code is this win function. So this is something we need to pay attention to, because this is what gets us this is what wins the challenge for us. And we can tell that that this is what we're looking for because, first of all, it references this file over here and these characters. It does a printf function. It says you win, and then it opens up the file. So whatever file, well, the file that's in question here is flag.txt, and it reads the file, and otherwise it says cannot open file. So what we need to do is we need to create a file called flag.txt in this directory so that we can get this function to do everything it's supposed to do. And then what does it do? It reads the contents from the file using this function right here, fgetC. And this is what we want to trigger. And in this particular challenge, we need to figure out where in the program, in the memory, this function is, so that we can feed this to the program, because the rest of the program does this. It does the main function here. So the main function in this case, it prints this message, enter the address in hex to jump to excluding the 0x. So 0x is the hex prefix, and it's going to take your user input by using scanf, and it's going to save it as the VAL value. So it's going to be this integer over here. So it's going to print out what you provided to the program, and then it's going to redirect the program execution to whatever address you provide to it. And if you provide the address of the win function, then it's going to execute the win function, and then you win. Okay, we got ads on Twitch. When ads run on Twitch, we run them on YouTube. And we also do a little bird video. How about these birds? This is one of my favorite little guys from the summer. He's the Stellar Jay with the broken leg. Anyways, enjoy the music and the birds. We'll be back in about a minute or so. So these Stellar Jays are very, very active in the summer. They usually come around. They know where to find the food now. So they've been back year after year. They come and they gobble up all the peanuts, and they hide them all somewhere so that they can get them later when they're hungry. Birds have to be very careful not to overeat, because if they overeat, then they can't fly, and that's a very bad thing. And that's why they hide food all around, so that when they get hungry, they can go back and they can find the food that they hid and they can eat it. Anyways, let's put the birds away and let's continue on with their hacking challenge. Okay, so if we know what we need to do inside of this challenge, we need to locate the address of the win function and then provide it to the program to execute the win function and give us the contents of the flag. So let's go ahead and exit out of the text editor. So it's going to be Control X to exit out. And we know we need to create a flag file inside this directory. So let's do that. So we're going to echo out something something inside of the flag.txt file like this. So for because we're HackerFrogs, we're going to obviously reference that we're HackerFrogs. So we're just going to call this HackerFrogs flag get, and we're going to save this output to the flag.txt file. So if we read flag.txt, and then it just says HackerFrogs flag get. Awesome. What we want to do is we want to use the program over here, picker4, and we want to get it to access the flag to give us the contents, because this is simulating what happens when we actually interact with the program on the remote server. So let's go ahead and, first of all, what we need to do is we need to understand a little bit more about this binary. And so binary programs, otherwise known as executables, these are all very synonymous things. When we say program, when we say binary executable, when we say executable program, we all mean the same thing. It's basically a program that we can execute on the computer. So we can use this command, rabin2, to get some information on this program, picker iv. So rabin2 -I for $I for information on picker iv. We give this command, and it gives us a lot of information about this particular program. So it tells us the architecture of the program. It's x86. x86 is referring to the chipset, or the CPU architecture. Most PCs and laptops use x86 architecture, but Mac computers and laptops use ARM architecture. It's basically a different type of computer chip, and each different computer chip has different instructions that it runs. So it also tells us that this is a 64-bit program. So older computer operating systems ran with 32 bits, but modern operating systems run with 64 bits, and this is a 64-bit program. Often in these kind of trainer CTF challenges, you run into a lot of 32-bit programs, but in this case, we're dealing with a 64-bit program. And it tells us which compiler was used to create the program, so GCC. And another important thing that we have to note here is that this program uses little endian byte order. And little endian byte order means that all the bytes they go in from the right to the left instead of the left to the right, which means we basically read in or punch in all of our instructions backwards. When we think about big endian byte order, it goes from left and then it moves to the right. But in this case, we're using little endian byte order, which starts at the right and then moves to the left. This is important because if we screw up our endian order when we do these challenges, we're going to have a very, very bad time. Okay, so we don't need to pay attention to anything else in this output here. So what we're going to do is we're going to examine the program using the Radare2 debugger. So it's R2-D-A to analyze the thing. Then we're going to run it on picker-iv like this. So if you're wondering, this is the command that we use to open up the program in Radare2. So we're going to do some... so inside of Radare2, there's a lot of stuff we can do. One of the typical things we do once we finish analyzing the program is we do this function. We do this command to take a look at all the different functions in the program. So it's AFL, it stands for All Functions List. And there's a lot of different stuff in here. We can just cruise on up to the top. And we're going to see that along with our main function, where is it? Our main function is over here. It also tells us the address. So it tells us the memory address where the function is inside the memory. And this is the one for the main function over here. This is a hex number, and all of the memory addresses are going to be hex numbers. So we can tell that something is a hex number because it's prefixed by this 0x over here. And the other thing that we need to do is we need to figure out where the win function is. Because we know from analyzing the code that if we can feed the program the location of the win function, then we will win. So sim.win is the function we're looking for. And this is the address right here. And we found it using the Radari2 debugger. There are a few different methods we could do to find this, but I like using the Radari2 framework because it has all the programs we need to do analysis of these binary executable files. Okay, so we've got the address of the win function here. We're just going to copy it. And then this is actually all we need from the Radari2 program. So we're just going to exit from here. So exit. Do you want to quit? Yes. You want to kill the process? Yes. Okay. So let's take a look at exactly what we got from the debugger. So we got this memory address. So this is the memory address in big endian order. So this is read from left to right. The problem is that we're dealing with little endian order, where everything's going to be backwards. And when we try to input something in little endian order, we have to remember that each pair is going to be 1 byte. So this is a byte here, and this is a byte here, this is a byte here, and this is a byte here. So that's 4 bytes. So 1, 2, 3, 4 bytes. So if we do this in opposite order, in little endian order, we have to go 9E, and then we need to go over here. This is 1, 2, and over here 4, 0, 4, 0, and the last one is 0, 0, like this. So this is the address in little endian order. Okay, so now that we've got this little endian order, we know that we can feed this to the program to get our to win the challenge. Let's copy this, and then let's run the program. So we're just going to run the program /picker-iv. Enter the address in hex to jump to, excluding the 0x. Okay, that's fine. We're just going to paste in the address, then hit enter. And it says you inputted something. Segfault triggered exiting. Okay, so I think the problem here is that we don't need the extra 0, 0 at the end. So let's go ahead and try just putting in those 3 bytes. That's interesting. Let me take a look at. I wonder if I copied the address for the win function incorrectly. Hold on. Let's go ahead and use Radari2 again. Okay, so let's take a look at the function addresses. So simwin is main is here. Simwin is here. 9E, it should be 9E1240. Okay, I'm just going to copy this to the chat just so I can retrieve it later maybe. And we know that the main function is here. Just in case this is the wrong function, I'm going to take a look at the contents of this function here. So we're just going to do a little inspection. So print disassembly function at simwin. Okay, so this is the function that we're looking for. So it says U1, and then it prints out the flag K. So this is, yeah, this is the function that we want. It's at this address right here. 9E1240. That should be it. Okay, let's exit out of here. Let me inspect the let's inspect the binary one more time. Oops. Okay, so the endian order is little endian, so it should be... Yeah. I'm not too sure why it's not working, but let's go ahead and run the thing again. Okay, so enter the address in hex you want to jump to, excluding the 0x. Excluding the 0x. So it should be 9E followed by 12 followed by 40 followed by 00. Maybe we don't need to put it in little endian order. Let's try big endian order just to see if 00 40 12 9E. Oh man, this was a big fake out. There must have been something in the code that that told it that you're supposed to put it in big endian order. But anyways, we managed to get the flag. For some reason, it wanted big endian order. That's a bit confusing to me. But anyways, we can get the actual flag by contacting the server. So over here, we need to launch the instance inside the Picker 4 challenge. After we do that, we should probably contact the server with the netcat command over here. So after we start the server, it's going to give us our netcat command to connect to the server. So let's copy that. Let's go over to our web shell. In the web shell, we're going to paste in the command. Then we're going to contact the server. This is the same program that we've been examining. The only difference here is that it's running in the server that has access to the actual flag. So we just need to copy the memory address that we got before, paste it in, and it says your input is this, you won. It says never jump to user supplied addresses. Okay, so we can copy the flag, and don't copy my flag. You should use your own flag, because I'm pretty sure this part of the flag, it's different for every user. So you won't be able to use my flag even if you copy it. We'll go over to the challenge description here. Neems asks, "What is that?" So that's the that's the address that we need to paste into the binary to get the flag. Okay. Well, I need to copy it from the web shell. Sorry. Okay. Let's grab this. Let's copy it, and then let's go over to the challenge. I'm going to paste in our flag, submit the flag, and then we're finished. Okay. So let's cover one more challenge that is going to be slightly more difficult than the previous challenge. Let's take a look at this challenge from ROP Emporium. So ROP Emporium is another great place you can go to learn about binary hacking. Neem says, "Can you walk me through real quick? I'm actually taking a class on that right now." So are you talking about class on binary hacking? So what did we do here? So in this challenge here, we downloaded the 2 files, and we took a look at the code inside of the C source code here. And in the C source code, we saw that there was a win function over here that gives us exactly what we want. And we know that we need to access this function. The binary address. Okay, so the binary address. Let me illustrate. So first of all, let's see. We'll use Radari 2. We're gonna take a look at inside this binary, and we're gonna talk about where the different instructions are inside the program memory. So after we analyze the binary, we can take a look at the functions and where the functions are inside the program memory. And the program memory is just a bunch of, they're basically little locations where we can store program data. So the main function over here is located at this memory address, and the memory addresses, they're all hex numbers. So 0x means hexadecimal, and then the rest of it is going to be a big hex number. So for example, this hex number, and then we'll notice that there's a win function over here. This is at a lower hex number, I think. This is lower, yeah. So this is a smaller hex number. And basically, these are little spaces inside the program memory where we store our code. I hope that makes more sense to you, Neems. If it doesn't, let me know, and I'll try to find a way to explain it better. Anyways, let's go ahead and move on to the next challenge. Okay, so the ROP Emporium is a great place to learn about binary hacking challenges as well. And let's see. We're going to be doing this challenge. So there are a bunch of different challenges of increasing difficulty on this website as well. And looks like I need to just access this. Okay, so they got challenge 1, 2, they've got 8 different challenges on here, and the first challenge is ret to win. It says here, ret to win means return here to win, and it's recommended you start with this challenge. Visit the challenge page by clicking on this card. And the great thing about this website is that you can actually download challenges in different architectures. So they've got 4 different architectures here. They've got x86, they've got x86-64. The difference between this is just 32 bits versus 64 bits. They've got ARM v5, which is the chipset that Mac and iPhone likes to use, and MIPS. MIPS is an architecture that's used by, I'm not too sure what kind of devices use MIPS. Is it industrial controllers or something? Like basically low-level circuits use MIPS, I'm pretty sure. But anyways, we're going to be solving the x86 version of this challenge, so we can just click on this to download the file, and let's copy it over to our own directory. So unfortunately, we won't be using the Pico CTF web shell for this challenge, because even though the Pico CTF web shell is supposed to be used for solving Pico CTF challenges, but we're doing a ROP Emporium challenge. So you're going to need to use, you could copy something over to the web shell by, I don't know. Let me, okay. Maybe I shouldn't demonstrate how to do this because it goes against the terms of service for Pico CTF. Anyways, what you should be doing is you should be accessing this challenge on something like a Kali Linux machine. And what we're going to do is we're going to move the zip file for the challenge over to our directory here. So move downloads over here. So this is ret to win 32 when ret to win 32.zip. We're just going to unzip this thing. And we got flag.txt here, and we also have the binary program ret to win32. So this is already executable, so we don't need to mess around with it anymore. Yeah, this is already executable. And what we're going to do is we're just going to run the program ret to win32. And it says ret to win by Rob Emporium x86. For my first trick, I will attempt to fit 56 bytes of user input into 32 bytes of stack buffer. What could possibly go wrong? You there, may I have your input please? Don't worry about null bytes, we're using read. So the thing with this challenge is that we don't have the source code for the challenge, so we just have to kind of guess at what's going on in the program. We could take a look at what's going on in the program by using Radare2 and examining the assembly code. But this is essentially the same as the previous challenge, where we have to access the memory address of the Win program to get access to the Win program and finish the challenge. So we don't know what we're supposed to supply here, but it says thank you, and then it reports that there's a segmentation fault, which means we crashed the program. So first of all, what we need to do is we need to examine the binary to see if there's anything super special about the environment for the binary. So it's going to be rabin2. This is the command over here. I'll just paste it in the chat, just in case you want to take a look. So just like the previous challenge, it gives us a bunch of information about this binary. So for example, this is x86 architecture, but this is only 32 bits. This is a 32-bit program, which means that the memory registers are going to be slightly different than if we use a 64-bit program. But the basics are essentially the same. So the other thing we need to take note of is that this is also a little endian system. So all the bytes are going to have to go in opposite order when we're entering them in. So let's go ahead and examine the program using Radare2. So Radare2 -da ret32 ret to win32. I'll just copy this over just in case you need a reference. Okay, so we've analyzed the program because we gave this flag over here. So we're just going to do AFL to take a look at the functions. We've got the main function over here, and we've got the win function. Okay, we've got the ret to win function over here. So basically, like the previous challenge, we need to supply the memory address of the ret to win function in order to finish the challenge. So what we need to do first is we need to figure out how many bytes we need to use to overflow the buffer. So this is a buffer overflow challenge. We basically want to overflow, like send a bunch of input, and then at the end of the input, when we get to the IP register, the instruction pointer register, we want to put in the memory address of this particular function in little endian order. So for example, this would be whatever this is. So this is the this here is the memory address in big endian order. So for little endian order, it'd be 2C, and then 86, and then 04, and then 08. So we would punch it in like this: 2C, and then 86, and then 04, and then 08. So we're going to send a string that kind of looks like this. And the problem is that we need to figure out the number of padding or offset that we need to send before we send this actual memory address. And we're going to figure this out with a little program called rag2. So rag2, we're going to give it a pattern, and we're going to create this pattern of of letters to send to the application. And for some reason it doesn't feel like running this program inside of here. Huh. How about we try a smaller number? Nope, doesn't feel like running. Okay, it looks like we're gonna have to get out of here and then run the program. So this is the program we're going to use to create a little pattern. So this is a pattern of letters, and the pattern of letters is predictable, and we can use the same program to analyze the pattern of letters when we find it inside of the memory register to figure out how large the offset we need to supply to the binary is. So we're just going to copy this. And if you want to make one of these patterns yourself instead of Kali Linux, then you can do this. Anime Life says, what are you doing? So we're doing some binary hacking right now. We've got a program that we can do a buffer overflow on. And if we can do a successful buffer overflow, we can get the program to run functions that it normally doesn't run. So we've got our pattern of letters over here. I'm just going to copy this string, and then we're going to debug the program. So we're going to use Radare2 to get back into the program. We're going to run the program. So we use the DC command to run the program after we start the debugger. And it's going to ask us for some input. So we're just going to input the long string of the long letter pattern over here, and then it crashes the program. So it says signal 11 error number 2. So this is a crash. So we crash the program. After the program crashes, we're going to see if this input is in the memory registers. So we're going to use the dr command here to take a look at the data in the registers. And we're going to see this pattern in the instruction pointer. So it says here EIP. This is essentially the instructions that are going to be executed next in the program. We have an ad on Twitch. When we have ads on Twitch, we do ads on YouTube as well. And we also play some bird videos. So I love my birds. Let's watch the birds have a little argument over here. And we're going to be back in about a minute while the ads run. I'm just going to have a little bit of water while that happens. Enjoy the music and enjoy the birds. If you have any questions, feel free to type them in the chat now, because we're taking our break. But Anime Life, hey, welcome to the stream. I don't think I've seen you here anymore. I don't think I've seen you here before. Let's give you a fun little video redeem. How about a Hack the Planet? There you go.
Hack the planet! Hack the planet!
Anime Life says, I'm new and this is overwhelming. No worries, no worries. If you have any questions about anything we're doing, ask us. Tell me exactly what you don't understand. I'll try to explain in language that you can understand. Nathan says the same. Okay, overwhelming, no problem. So we're trying to let me put the birds away. Dagger RB says, what is live even about? I just got here. Yeah, so we're doing some buffer overflow over here. So basically, in this program, we can send a bunch of characters to it to crash the program. So crashing the program by sending a bunch of characters to it, this by itself isn't super bad. The problem is that if we're able to crash the program by sending a bunch of data to it, then we could potentially get the program to run other commands. And this is what we're trying to identify over here. Let's see. Norak says, can you crack any software with C? So when we talk about using coding for hacking, what we really mean is that we're identifying the problems in C language, or programs that are written in C language, to identify security problems that we can potentially hack. And so, like I mentioned before, so this is a buffer overflow challenge that we're doing over here. And if we send enough of these characters over here, we can crash the program. What we want to do is we want to send just enough characters to crash the program, but also include some instructions at the end of the line of characters here. And this is how we do it. So we sent this pattern of characters and we crashed the program. After that, we take a look at the next instructions that are going to be executed, and that's going to be in the EIP memory register over here. So when we're examining the program, everything's happening inside the program memory, and the program memory for the next instructions has these letters inside of it. So what we're going to do is we're going to find out which characters are in there, and it's going to tell us how many characters we need to send to start sending characters into the instructions for the program. Thank you very much, Dagger RB, for subscribing. Thank you. And you know what? Here you go. Let's give you a little Nyan Cat, because we love this meme. And Meow, Meow. This is a Nyan Cat for you, Meow. Thank you very much for subscribing on YouTube. Okay, so the Nyan Cat should be coming up. There you go. Okay, so we've identified that we need to send 44 characters to the program before we can send in our own instructions. Anime Life says, I feel like you're talking some mystic language. So, unfortunately, you do have to know, like, there are some prerequisites to do in hacking. So you need to know the lingo, you need to understand about computers and computer programs and stuff. I think anybody can learn. Do I need any prerequisites? So we're talking about the way memory works for program execution. So every time you run a program, all the instructions for the program that it needs to run, it's going to be put into your computer memory, and then that's going to be a place where your CPU gets access to those instructions so it can run them. Dagger RV says, is vibe hacking a thing? Vibe hacking is a thing. You could do vibe hacking. It's not recommended. So I've got my my AI over here. I could ask it, so for example, if I've got like a hacking challenge or something, I would ask it, I don't know, something like this. So maybe we've got this challenge, and I could ask it, so for this challenge over here, I could download some source code. And let me just illustrate, just really quickly. So we got the C language file that was used to create the program. I'm just going to download it real quick in another terminal. So this is the C code that was used to create the program for the challenge. And if you can understand what exactly is going on in this code, then you can understand what exactly you need to do to finish the challenge. So if you wanted to, you could vibe code this by saying you can grab the code here, then you could go to the AI, and you could ask something like, this is code for a binary hacking challenge. How do I solve this? And then paste in the code. Nan says, I think vibe hacking is just being a script kiddie. It's even worse than being a script kiddie, because you're not necessarily going to get the right answer from the AI, because the AI isn't necessarily going to give you the correct steps to finish the challenge. The AI can identify vulnerabilities in here, and it will identify what it thinks is going to be the solution for the problem. It'll tell you exactly which commands you would be using to inspect the binary program. But even if you follow the instructions that the AI tells you to the exact letter, it's not necessarily going to give you the answer that you want, because you have to understand a little bit about the concept of binary hacking. And if you don't, then the stuff that the AI tells you is just going to be a bunch of gibberish. So we're gonna let's go back. So you can do vibe hacking. It's not recommended. What were we doing over here? So okay. So this is so in this other challenge over here, we need to use the buffer overflow, send a bunch of stuff, and then we need to give some instructions to the program. So the instructions are going to land in this memory register over here, the instruction pointer. And what we need to do is we need to fill the instruction pointer with the address of a function that we want to run. And we identified that the function that we want to run is this function right here called ret2win. It stands for return to win. This is a type of binary hacking challenge where we just need to make the program run a specific function to win, right? And this is the memory address that we need to provide to the program. So we also need to figure out how many bytes we need to send to the program before we give our instructions. And in this case, it's going to be 44 bytes. So this is what we're going to do. We're going to use the Perl program to print out some bytes for us. And the problem with these bytes is that the bytes aren't necessarily something that we can print out. These bytes are not going to be on your keyboard, so we need to refer to them by their hexadecimal number. So this is hex number 08, hex number 04, etc., etc. We're going to get the Perl program to run this for us. We're also going to have the Perl program print a number of padding bytes equal to exactly the number of bytes we need to print out to overflow the buffer, and then put our own instructions in the instruction pointer and run the program. So in this case, we're going to print 44 of these A characters, and then we're going to supply the address of the memory, the memory address of the function we want to run, which is the ret2win function. We're gonna feed it to the binary with the pipe over here. And for anybody who is looking to learn about cybersecurity, the first thing you should learn how to do is how to use some Linux, because the cool hacker OS is Linux, and the cool hacker OS that everybody likes to use is a version of Linux called Kali Linux. It's basically a version of Linux with a bunch of security tools on it, which a lot of people who are learning about cybersecurity... Oh, thank you, Anime for Life, for redeeming the Nancat. Thank you very much. But yeah, so if you want to learn about how to hack stuff, you probably don't want to start with binary hacking. You probably want to start with Linux. Learn how to use your Linux, and learn a little bit about programming. So I teach a couple of courses over on my YouTube page. So YouTube at the Shy Hat over here. And if you actually, a good place to learn about the basics of prerequisites for learning cybersecurity is over at the Pico CTF website. So Pico CTF is a very, very famous cybersecurity education platform, and it's actually run by Carnegie Mellon University, and that's a very famous university for cybersecurity in the United States. If you want to sign up for an account over at Pico CTF, you can do so at the following link. Let me just grab the link for you. Go over there and make a free account, and then afterwards you can take a look at some of the walkthrough videos that I made for Pico CTF. They begin very, very easy. It's basically just accessing the Linux terminal and figuring out how to do a few basic commands. But after a while, you'll start, gathering a collection of these commands, and then you'll be able to do more and more. Linux is very expensive dishware. It's advised not to hack it. Thank you very much, Ken PDX. Thank you. So these are Pico CTF challenges. This is the full playlist. If you start working your way through the challenges on this playlist, they start off very, 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 very easy. But after a while, they become more and more difficult. So it just starts off with stuff like opening up the interface on Pico CTF, and then using some programs to access some remote servers, how to read files, how to use different commands inside of Linux. And after a while, you'll collect a number of commands. Eventually, you'll be able to do more and more stuff with your with Linux, which is kind of the stepping stone for becoming good at doing cybersecurity stuff. But anyways, let's go back to our challenge, because we need to finish our challenge and then move on to our last part of the live stream. Where are we? Okay, so in the buffer overflow attack, we send a bunch of characters to the application to crash it. But while we crash it, we're going to leave some instructions in the instruction pointer here, and the instructions are going to give us access to the win condition for this challenge, which is the flag file. Okay, so let's see. Anime Life says, I only know basic Linux commands like cd, ls, rm, mkdir, touch. Yeah, so this is how you start. You just learn how to use the operating system, and after a while, you're going to be able to use the operating system to do all sorts of cool stuff. So Mohammed Shamir says, can you do more stuff on heap exploitation in the future? So heap exploitation is a little bit more advanced than what I do. So there's inside of binary hacking, there's stack buffer overflows and heap buffer overflows. And I've only ever done stack buffer overflows. I've done some heap stuff, but it's not something I'm super used to. But anyways. Oh. Huh, okay. So here we need to... Sorry. Sometimes in Linux you need to specify the directory that you're running the program in. In this case we're running it inside the current directory, which is /. Okay. Okay, so it says, well done, here's your flag, and it gives us the placeholder flag for the challenge here. I don't think there's an actual flag we can get for the ROP Emporium challenges that we're doing over here. But if you're interested in learning more about this challenge, you can access it from this webpage right over here. Okay, and if you have any questions about anything that we did today, feel free to leave the questions in the comments or in the live chat. I'll try to answer the questions as best I can. So yeah, Anime Life, if you want to learn more about hacking, you basically build on the knowledge you already have. A good foundation for learning about hacking stuff is to learn Linux and then to learn Python. So Python is a very, very popular programming language that a lot of people use, and I think I've got a little course for it as well. Wait, let me go back. Thank you very much for following DX Mostracero. Thank you very much. So let's see, I've got my little HackerFrogs after school classes over here. Python programming, sure. Let me copy the playlist over here. So another good place to learn about Python is this course over here from Skills for All. Python. So Python Essentials 1. So let's go ahead and grab this link. So this is a course that's sponsored by Cisco. It's a big network, a big American networking hardware company, and they supply a lot of the networking. Oh, that's weird. Another thing I'd like to point out to everybody is that we have a Reddit as well. So we're on Reddit, and we're at HackerFrogs. So every week we publish our streaming schedule over here. We do 3 streams a week. We do Monday, we do Linux stuff. On Wednesday, we do web app hacking stuff. And on Friday, we do variety stuff. But we also do Windows hacking as well. And we're going to be moving into our Windows hacking section in just a little bit. So if you want to keep up with what we're doing from week to week over on the channel, then you can use the Reddit to do so. Dagger RB says, do you ever do game hacking? So I would like to do game hacking in the future. But the first thing I want to do is I want to finish my regular old binary hacking course first, and then after that I'll start doing some. I'll look into making a course for game hacking. But yeah, if you're interested in game hacking, another really good place to look for learning about cybersecurity stuff is tryhackme.com. It's a place where you can learn a lot of stuff for free on TryHackMe. They have a paid service as well, but there's a lot of stuff on the TryHackMe website that's completely free. So on this site, you can search for, let's say you're looking for game hacking. So game zone, hack Fendi Banal. They've got a few different challenges over here that talk about how to hack game executables, and I think one of the good ones was from the Christmas event. So the Christmas event over here, actually, you know what, it's probably easier if I just Google this. So TryHackMe game hacking advent of cyber. Okay, so let's see, which day is it? It's day 19. Let me just look this up real quick. Sorry, this was from a Christmas event, and in the Christmas event, you were able to win all sorts of prizes. Let me. Oh geez, this is too small. Okay, we're looking for day number 19. So day 19 is over here. Okay, so what you want to do is sign up for TryHackMe over here. After you sign up for TryHackMe, access this link here, and then go over to task 25 or day 19. This is talking about game hacking, and it's actually pretty in-depth. They're going to be talking about how you can use different programs to hack executables while they're still running, using a couple of different programs. But yeah. Anyways, let's go ahead and finish this out over here. So we just illustrated some binary hacking by doing a buffer overflow attack. And now we're going to be moving into the final section of today's stream. We're going to be doing some Windows hacking. So this is going to be a bit different. This isn't going to be a walkthrough. This is going to be a challenge. So it's a challenge I've never seen before, which means I'm going to have to use all of my skills to figure out if we can hack this Windows machine to the highest level of the highest level of privilege. And another fun little wrinkle in this challenge is that this is a Spanish version of Windows that we're going to be hacking against. If you want to join in yourself, then you're going to need to have Anime Life says, TryHackMe is a little laggy in the Kali VM. Anime Life, are you working inside of a Kali VM right now? I guess, yeah, TryHackMe is a bit laggy on my Kali VM as well. So, or is that what we were talking about? Because I am working inside of a Kali Linux virtual machine right now. And another thing that you want to do if you start learning about cybersecurity or about hacking is you want to learn how to work with virtual machines. So virtual machines are basically running a computer inside of another computer. And this is a really great learning tool because you can work with different operating systems that you normally wouldn't get access to by running them as virtual machines. So if anybody's done emulation before, so if you've done emulation for Super Nintendo or if you've done emulation for PlayStation, virtual machines are kind of like that. You're emulating another computer. You're using a computer to emulate the hardware for another computer. And that's what virtual machines are. But, yeah. Let's see. Anime Life says, my laptop only has 8 gigabytes of, oh, yeah, that's true. If you wanted to work with virtual machines, you need a lot of RAM. You need a lot of computer memory, because the virtual machines use their own memory. Let's see. Versus Kit says, what is the host OS? Are you talking about my host OS? So when we say host OS, we mean that the OS, the operating system that's at that the original system is using. And in my case, I'm using Windows 10. So everything that I'm doing is on top of Windows 10. So this Kali Linux machine is on top of Windows 10, and I'm using VirtualBox to create a bunch of virtual machines. So, yeah, Anime Life, if you wanna learn about virtual machines, but you don't have very much, you don't have very much memory, that's fine. You can learn through TryHackMe, and TryHackMe lets you have access to a Kali Linux or something very similar to a Kali Linux virtual machine for about an hour a day. It's called the Attack Box on TryHackMe. But yeah, you can. It's a great place to learn. And another thing that you can do is you can access PicoCTF, because PicoCTF has a virtual machine that you can use on their website as well. It's called the Web Shell. So it's basically a Linux machine with a bunch of security stuff on it as well. But this is all free, and you can, because you're accessing it through the web, it doesn't matter how much or how little power your own PC has, because you're using their hardware. KenPDX says, I just hack for my Mac. If I need a particular tool, it's pretty much always available via brew or pip, since I usually end up using the same handful of tools all the time anyways. I don't see the need to have every possible tool pre-installed. So KenPDX is, I think KenPDX is a pretty experienced network engineer or network administrator. They've been working in tech for quite a while, so they know how to get the stuff working on their computer system. But for people who are new to cybersecurity, it's probably a lot easier to use the Kali Linux virtual machine, because all the tools are there. They're all pre-installed. You don't need to go looking for stuff. But I understand KenPDX is in application security. Cool, that's awesome. Yeah, I had a feeling that you were a person who has been working in the industry, in the tech industry, anyways. I don't know about whether or not you're working in cybersecurity, but I think you'd been working in tech for quite a while, because you give off that kind of vibe with your messages. Anyways, let's go ahead and start our Windows hacking journey. So what I'm going to do now is I'm going to start a bunch of, well, let's get out of here. And if anybody has any questions about cybersecurity stuff, feel free to type it in chat. I'm hacking Windows. That's what I'm going to be doing in the background. But if you have any questions about any cybersecurity stuff or getting into cybersecurity, you feel free to ask any questions about that as well. Bandit says, custom attack boxes are always better. Yeah. So if you know exactly what you need, then you're probably better off installing exactly the software you need for your security stuff, as opposed to using an all-in-one package like Kali Linux. But Kali Linux is good if you don't want to bother keeping track of what you have installed and you just want something that has all the security tools. You can certainly save a lot of storage space by not installing everything on Kali Linux. But let's make a bunch of tabs. Bandit says Kali is good for learning if you know for sure you won't expose yourself using it. Yeah, that's the other thing about Kali Linux is that you can pull some serious security oopsies with Kali Linux if you expose it to the internet. Hopefully, you're not exposing it to the internet from like an exposed port point of view, anyways. Via says, "Oh yeah, 8 gigabytes isn't enough for Windows 11." Yeah, so Windows 11. Any version of Windows is going to be a big memory hog, so you need to have a lot of memory on your computer to run Windows, and especially if you want to run Windows virtual machines. The Pajaro 88, hello, hey, what's up? We're just about to start our Windows hacking stuff, so I'm just going to name a bunch of these tabs for different tools I'm going to be using. So this one's going to be Nmap, and this one's going to be for web enumeration. And let's do one for netexec. And let's do one for, I don't know, brute forcing. So Anime Life says, I'm already using WSL for web development. Oh, are you learning about web development, Anime Life? Because web app security testing is a really big specialization instead of cybersecurity. Let's see, Bandit says, I've seen people get caught before because they use CLI tools that do things like report the host name, which is default Kali on red teams. That's the thing, Bandit. If you're working on a red team, you have to be very careful about your tooling. Anyways, we got an ad running on Twitch. So when ads run on Twitch, we also run them on YouTube. And we're just going to take a minute break while the ads run on both platforms. And in the meantime, let's go ahead and watch some lovely birds. Here's a great woodpecker that is found basically all over North America. You probably have some sort of woodpecker that looks like this in your area if you look hard enough. But I'll be back in a minute. Just gonna have a little water break. But I love these woodpeckers because the male woodpeckers have this great red mustache. So if you take a look at this guy, he's got a red band over here, and there's actually a difference between this kind of woodpecker, the northern flicker woodpecker, on the west coast versus the east coast. On the west coast, you're going to see males with a red mustache, and on the east coast, you're going to see males with a black mustache. So I guess that's the whole East Coast and West Coast rivalry going on there. Anyways, let's put the birds away, and we'll show them again in about 30 minutes when we take our next break. Okay, so what are we doing? Bandit said that on red teams, he saw people get caught because they were using CLI tools that report host names. Yeah, so when you're on a red team, and red teams are basically the most secretive type of offensive security testers. they're trying to break into networks, and they're paid by companies to try to break into networks or web applications, but they're also trying to do it secretly and without getting caught. And the thing about doing red teaming versus doing regular pen testing is that regular pen testers don't necessarily need to worry about getting caught by the defenders. But yeah, stealthy, of course. But people on the red team need to make sure that they're not detected while they're doing their hacking. So that's the big difference, is that a lot of tools need to be... A lot of these security tools, they need to be adjusted so that they don't reveal, well, what kind of tool it is and who is doing the scanning with it. But yeah, that's red teaming versus pen testing stuff. Okay, what else do we need to do? I think we need maybe a research tab and maybe a shell access tab as well. So the reason why I put everything in these different tabs is that I like everybody to understand what tools I'm doing or what tools I'm using while I do my my hacking stuff over here. Just to make it extra fancy, I'm going to make every one of these tabs a different color. And then we can get started. How about this one's purple and this one's red? Okay, so the next thing we're going to do is we're going to deploy the actual virtual machine that we want to be hacking against. So I downloaded the virtual machine from the Hackers Labs website over here already, and I deployed it with I installed it using the VirtualBox software. Next thing we need to do is we need to actually deploy the machine, and then after that we can start our scans against it. So the way we do these hacking exercises is that we put our attacker machine, in this case it's a Kali Linux virtual machine, and the vulnerable machine, which is the Windows virtual machine that we're going to be hacking, on the same network. And then we need to locate the machine, and then we need to do our hacking. Because if machines aren't on the same network, then they can't communicate with each other. And if they can't communicate with each other, we can't hack against it. Okay, so we actually get some information right off the bat. So the virtual machine here, this is Windows Server 2008. It's not a modern version of Windows, but actually 2008, what version of Windows is that going to be? Is that going to be Windows 8 or is it going to be Windows 10? I should probably look that up. But this is an older version of Windows. This is a server version of Windows, and this is the one that we're going to be hacking against. Let me just look that up real quick. So Windows 2008 server. Okay, so it's released by Microsoft and the support ended on so this is So is this Windows 10 or is it Windows 8? Okay, so server 2008 is Windows 7. Or maybe it's Windows 7. Anyways, let's go ahead and locate the machine on the network. So we're going to be using a tool called Nmap to figure out where the machine is on the network. I can take a look at all of my network interfaces by using the IPA command. And I think the network that we're dealing with is on the ETH1 Vista. Vista? Let's see. Turd for Ferguson. Turd Ferguson? Turd Ferguson. Is what? Anyways, welcome to the stream. Hey, nice to see you here. Have a hack the planet, because that is part of our theme.
Hack the planet! Hack the planet!
Okay, so So this is the interface that we're going to be using to interact with the machine. We don't have an IP address for this network right now, so we're going to have to get one by using the dhclient command. So we're just going to request an IP address. So after that, we have an IP address on the network. We are now at this IP address. So we need to, we're going to use nmap to scan the network. It's a funny, it is a funny name, Turd Ferguson. Anyways, let's use nmap to scan the network. So this is the network IP range that we're scanning against over here. We're using nmap to determine to do what is called a ping sweep. A ping sweep basically lets you know which computers are online on a particular network range. So when we run the ping sweep, we get these results. So all of our virtual machines are running Oracle VirtualBox. So this is our IP address on address number 4, and this machine on address number 3 is probably the machine that we want to scan against. So this is the IP address for the box we're getting hacked. Okay, so we're going to run nmap to scan all the ports, all the networking ports against this particular IP address. We're going to run it very verbose and get some versioning information. We're also going to run it very fast. So the nmap program is it's pretty versatile. We can run ping sweeps with it. We can also scan certain ports on a remote server, which is a remote server is basically any computer that's not your computer on the network. And we scan all the ports. We scan it very verbose. We scan it. We run common scripts and versioning information against anything we find, and we run it at a very fast speed. So when we run the nmap scan, it'll tell us which networking ports, which services are available on the system. Anyways, let's play some different music. Okay, so I'm gonna play the the soundtrack from the Muramasa the Demon Blade game. It's got some really fun and funky Japanese traditional music with a modern twist. I hope you like the soundtrack. Okay, let's go ahead and play this thing. Okay, sounds like we're going on a epic journey. So what do we have on this particular box? So we see a bunch of different networking ports open on the system, and we can guess what kind of networking services are being hosted on those ports. SMB client time, says Turd Ferguson. Yeah, we're going to be using SMB client for sure. We're probably going to be using NetExec as well. So these are different programs we can use for scanning against different services. So on Windows, you'll usually see port numbers like 135, 139, and 445 open, as well as a bunch of services on the 40,000 range, like this. For Windows machines, these are very common. What's not very common is port 80, which is web pages. It's actually pretty rare to see Windows machines hosting web services. Most of the web servers on the internet are being served by Linux machines, but there is a Windows web server. There is Windows web server software as well. We can probably check this out on our web browser by just picking up the IP address over here. Then we go over to our web browser and paste in the IP address, but we're going to tack on an HTTP in front of it. And it looks like there's nothing on the landing page for this website. Versus Kid says IIS is trash. Well, I guess. Well, I mean, it's not very popular for a reason. It's because, well, Windows machines are probably not very good for web development. There are a bunch of different reasons, but the reason why this error message and everything else is in Spanish is because this is a Spanish installation of Windows, and the website we got it from is a Spanish language website. So if you speak Spanish, let us know in the chat, maybe you can help us out. But for these kind of exercises, what I like to do is I like to use Google Translate. So the resource you're looking for may have been removed, its name changed, temporary and unavailable. Okay, we're going to be using a lot of this if we run into a lot of text on these challenges. But anyways, hackers don't let little things like language get in the way of getting their hacking done. So if we find some other language, we'll just translate it. We'll use whatever tools are available to us. We also found this unusual service on port 9999. This is not a usual port for services in computer networking. We probably need to take a closer look at this. So before we go ahead and take a look at some other services, we probably want to... Oh, I'm detecting some comments at the... Yeah, funny. So another thing that we can do when we encounter web applications like this is that we can take a look inside the HTTP source, and the HTTP source is basically the source code for a web page. And even though this is an error message, there's some funny stuff in the comments over here, and this is Pila Casuprimo. This is probably something in Spanish. So let me translate this. So this is the name of an endpoint. So Pila is the name of the... Pila means battery. Casi Primo? Prime stack, almost interesting. So we might have to be doing some stack buffer overflow on this box, because I was looking at before, the word pila can mean either heap or stack, and it kind of speaks out to me that we might have to do some stack buffer overflow to finish this challenge. Anyways, let's take a look at the endpoint that is being referenced over here. So we can tell that this is an endpoint because we've got a slash in front of here, which means that it's probably a directory. So we're just going to grab the name of this directory. We're going to tack it on to the end of the IP address and see if there's actually something there. So, oh man, okay. So we've got some directory listing. So directory listings, it basically means that if we navigate to a directory, we can see everything inside of it. This is web app vulnerability. And we see that there are 3 files that we can download here. And one of them is this executable here. We were taking a look at executables earlier today. And we've got a DLL file, which is a library file. We're gonna download all of these things. Copy this link. I'm gonna start downloading these files. Let's see. We do the research here. Download this file. Download the next file, which is vulnserver.exe. So we're going to download all these with the wget program. Web config, sure thing. Okay, so it looks like we weren't able to download the web config file. That's fine. We've got the other 2 files. So we've got essential function, I think that's what that stands for, .dll. It's a library file. And we've got the vulnserver.exe. Huh. I wonder where this comes into play. Okay, so we've finished our Nmap scan. So the Nmap scan tells us a bunch of stuff about the networking services that we found. So the networking services we found was port 80, which is the web page, and we've got the SMB service on port 139 and port 139 and port 445. So this is basically Windows file sharing. We're going to be enumerating against this too. So we need to figure out if there are any vulnerabilities on this service. Oreo Byte, hello, nice to see you here. You got the Bongo Cat. Awesome. Welcome to the stream, Oreo Byte. Nice to see you here. And why don't we give you a Nan Cat? Here you go. Welcome to the stream, Oreo Byte. Oreo Byte is a fellow streamer. Vuln server, is it buffer overflow time? I think it might be buffer overflow time. But to anybody who doesn't know, Oreo Byte also does live streaming on Twitch. Let's give them a shout out. There you go. So go ahead and follow their channel. They do streaming every once in a while. They usually do Windows hacking stuff. It's usually a lot more advanced than the stuff that I do. And they're pretty good at hacking that Windows stuff. Okay, so let's go ahead and... So before we move on, what I really want to do is I want to do some brute forcing against the web page service. So Oriobyte says streaming yesterday. No idea why Bloodhound DNS timeout issues. Oh, okay. I didn't see you online. Huh. What time were you streaming at? Let me know. Okay, so how are we going to do our web server enumeration? Let's do some Ferrix Buster. So Ferrix Buster is a tool that we can use for web page enumeration, and what it tries to do is it tries to determine what web pages or directories are available on the web application. So in this case, let's search for some Windows web server file extensions like ASP and ASPX, zip files, HTML files, etc., etc. And we're just going to try to figure out if any of these endpoints exist on the target. HTM. Okay. So it looks like nothing is here. Let's see. So Oriobyte says, I was streaming in the evening. The bug not showing up on InfoSec streams. Yeah, InfoSec streams is a website that we use to keep track of all the people who are doing InfoSec and cybersecurity on Twitch and YouTube. But for some reason, it's not working very well right now. Let me pull this up. infosecstreams.com, I think it's called. There you go. Okay, so it looks like it's working right now, but we've got a few different people doing InfoSec streams. Hack Smarter is a really good channel as well. They do a lot of YouTube content. Anyways, if you want to take a look at this website, there you go. Okay, so we've got not very many hits over here, but I'm just going to leave it running in the background. Maybe we can find some extra web pages or directories if we scan this long enough. But in the meantime, we can do some other testing. So my preferred tool for doing SMB enumeration, SMB being the Windows file sharing service, is called netexec. So netexec is basically a very useful tool for doing Windows pen testing stuff. vulnserver.exe on the web server. vulnserver.exe on the web server. Seems like you missed it. So we actually found it. We found it before. This over here, right? We found this endpoint on the landing page inside of a comment, and I found vulnserver.exe over here. We downloaded it. Yeah. No worries. We'll investigate that eventually. I just want to get the rest of my scans going first. Okay, so we're gonna run netexec, and when we run netexec, we need to specify usernames and passwords. We can run it on a few different common Windows services. In this case, we're going to run it against the SMP service, and we're going to figure out if we can access anything with no password. So maybe we can access something with no password. So let's see if we can get some file shares. So we were not able to get some file shares. Let's see if the guest account works. So we're just trying to figure out what accounts work on this particular Windows box. So because I've been testing against these Spanish language machines before, I know that the guest account in Spanish is called invitado. So invitado means guest in Spanish, or at least I think it does. It says status account disabled, so we're not going to be able to get any access as with these accounts. Okay. So what else could we do? We could try brute forcing for account names. Actually, it's difficult to let's try looking for users with no username or password. So we didn't manage to get any users. That's fine. Okay. So maybe scanning against SMB is going to be a bit difficult in this case. Orabyte says a 32-bit build of Windows. What's administrator in Spanish? Administrator is administrador. So it's like administrator, but with a D instead of a T. So let's try administrador. So it's just very slightly different in the spelling. So it says status log on failure. It's going to be very difficult to determine which user accounts are valid. We can't really... I haven't found a way to do reliable username enumeration through brute forcing on these systems that are not using Active Directory. If you're using Active Directory, we can do Windows user brute forcing with certain tools like what is it, curbrute? I think that the tool is called. But anyways, it says that Oreobyte, where did you see that it was running 32-bit Windows? Maybe I should be paying attention over here. netexec output. Okay, let me take a look. Ah, right. Okay, so this is the 32-bit. So this is Windows 6.0. Huh. Windows 6.0. That's and the name of the computer is this one right here. We've got a domain. So this is a version of Windows that came out when Active Directory wasn't super popular, I think. 187, hello, nice to see you here on YouTube. Welcome to the stream. Have a Hack the Planet. Welcome in.
Hack the planet! Hack the planet! Shut up again!
Okay, so SMB really isn't getting us anywhere, which is unfortunate because SMB can be a really nice source of information on these boxes. Updated version of Blue in MSF is only 64-bit. You can find 32-bit versions of Eternal Blue online. So if you're looking for Eternal Blue, which is a really popular SMB exploit, you can find it. So let's see. It looks like we've got this one over here, Windows 7 Blue. So this one is for Windows 7 versions. I think this one counts as but I don't think we're using Eternal Blue on this particular box. I think on this box we need to do some buffer overflow. But I guess, you know what? Eternal Blue is a type of buffer overflow attack, isn't it? Tommy, hey, what is up, Tommy? Nice to see you here on a Friday. TGIF, everybody. And Tommy, why don't you have a desert frog? Welcome to the stream. Okay, so let's go ahead and I think it's time to check out this other weird port that we found on with Nmap, which is this one right here. So port 9999, which is reporting the Vuln server. So this is probably the program that is that we found on the website, which is vulnserver.exe. Thank you very much for following, Turd Ferguson. Thank you very much, and welcome to the HackerFrogs. We'll give you a special video redeem too. How about go to hack? Hope everybody is having a great day. Everybody go to hack.
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
Okay, so so what exactly is this Vuln server program doing? So I'm not super familiar with hacking and doing buffer overflows against Windows binaries. I haven't done it in a while. I wonder if I can use Radare 2 to run this. I'm pretty sure I can't run exe programs inside of Linux. Well, don't think I. Yeah, we can't run. We need to run these in Windows. I guess we could run them with Wine. Anyways, there's an ad running on Twitch, so ads on YouTube as well. And let's go ahead and play some birds. There's a bird. That's a cute little guy. Okay, I'm just gonna take a little water break. We'll be back in about a minute or so. Oreobite says, if I did this with Radare 2, I would be impressed. I hear that Radare 2 can run with Windows binaries. You just have to use some plugins or something. I do like using Radare 2 over other debugger programs. But so we got this Vuln server program right here. I wonder if I can take a look at it with Radare 2. Okay, I cannot open this thing for writing. So we need So I'm just gonna research real quick. So Radare 2. Windows binary. Debug. Okay, so debugging using Radari 2 and Windows. This article will teach you how to debug our applications using Radari 2. How to install Radari 2 on Windows. Debugging Windows binary from Linux. Debugging Windows library from Linux. I just want to control the remote debugger Radari instance. You know what? Maybe let's ask the AI. Maybe the AI knows something something I don't. Okay. We want to debug Windows binary with Radari 2 in Kali Linux. What do we need to... Okay, so Auriobyte says the tool you would usually use could be cheesed in Linux, but it won't give you correct bad bytes, so it's not a good idea. Anyone in the same network could attack your machine if you're not careful. If something like if you're using something like the Try Hack Me box. So we're not using the Try Hack Me box. We're just using our regular old Kali Linux VM. But yeah, so one of the things we need to do is we need to get bad bytes when we do this kind of stuff. I remember doing a lot of immunity debugger way back when I was learning how to do buffer overflows for the OSCP examination. But here, I don't know. But what does the AI tell us? Okay, so you need a few things to handle the Windows PE format. Here's a guide. So we've got these packages here. Okay, so we need to emulate Windows binary stuff. Let's see if we can install this stuff. WineDBG. Unable to locate packaged WineDBG. It might be because the AI is hallucinating. Okay, downloading stuff. Sure is fun. This is where Linux is awesome. Linux is awesome because you can just start installing programs without having to shut down your computer and restart it a bunch of times like you have to do with Windows. Unfortunately, this is going to take a while. So if you have any questions about cybersecurity stuff or about any of the stuff that we've been doing so far, let us know in chat. Or if you just want to talk about certifications or what kind of fun stuff is happening in the cybersecurity world, let us know as well. Okay, we're just gonna leave this running. We're gonna come back to it in a little bit. What else do we have over here? So we were running netexec. I don't think we got anything from our scan with FerrixBuster. Yeah, we didn't find anything. Bandit says, pretty sure you'll need a debug server on the Windows side and use Radari 2 as a client in Linux, assuming that Radari 2 can act as a server or handle Windows debug server protocols. So this is probably a circumstance where we want to use a Windows system to do the debugging against Windows binaries. So before we do that, you know what? Maybe we can take a look at the service that's happening on port 9999. Okay, hey, Sick in the Mind, hello. Let's see. You will need to install Radari 2 in the Windows system. Sick in the Mind says they're back. Nathan says, sorry, this might be unrelated. I'm finishing up my freshman year of college, and I'm studying for Security Plus right now. Should I also go for Network Plus? Sick in the Mind says, been kind of lurking and working on my OSWA. OSWA is some heavy-hitting certificate stuff. WA is WOS. Let's see. Offensive Security, Web Adept, Web Assessor. Okay. Web 2000. So it's basically the advanced version of the web application certification from Offensive Security. Yeah. What kind of stuff were you working on? What kind of advanced stuff? So if you were to sell the course, Sick in the Mind, it's not the advanced one. What kind of ultra fun stuff do you get to do in this course, in the Web 200? So let's see. Bandit says could always use Win Debugger. Maybe. But at this point, yeah, just debug in Windows. Let's see, whatever works. Would like to see a solution without Immunity Debugger. Huh. Let's see, Immunity isn't even maintained anymore. So a lot of people like using Immunity for some reason. It is what they teach in... Thank you very much for subscribing, Light OS. Light OS. That name sounds familiar. That name really sounds familiar. Light OS, if you are the person who I think you are, please let me know in YouTube chat. But welcome to the team, and remember everybody, hack the planet.
Hack the planet! Hack the planet!
Okay, Web 200 comparatively covers a lot of similar topics to the Burp Suite Certified Practitioner certification. The only reason I took it is because it was part of my Learn Unlimited on my path to OSCE 3. OSCE 3. So OSCE 3 is Offensive Security something expert? Something expert? Bandit says X64 DBG is the new shiny. We're actually working with that earlier, like last week, like last Friday. Let's see. Light OS, yeah, I think you are who I think you are. Nice to see you live. We're just doing some Windows hacking over here. We've got a little, it looks like we're going to be dealing with some buffer overflow stuff. We're actually hacking against a Spanish language platform. So this platform is called thehackerslabs.com, and it's a Spanish language website where you get to download vulnerable virtual machines and deploy them to your network and do hacking against them. And yeah. Oribyte says, usually the default is a mix of mono and immunity and MSF tools. Okay. Offensive Security Expert. Offensive Security Expert, is that 2 levels above OSCP? Or is it 1 level above OSCP? The OSCE 3. Let me know. But yeah, we need to figure out what program. Technically 2 levels above OSCP. So that's so at the OSCE 3 level, does that mean you're writing up your own shellcode? You're developing your own hacks? Studying the Pen 300, which is a level up from OSCP, the OSEP cert. Okay. Alright, so we need to figure out which program we're going to be using to do our buffer overflow stuff. It's a lot of alphabet soup. Yeah, it sure is. Maybe, well, you know what? Maybe we could do... I have the, what is it? X64 DBG on here. X64. The problem is I don't know very much about how to use it. So I managed to get it installed on my Kali Linux system. The problem is I don't know how to use the program worth beans. I don't know how to use the program. Wine could not load kernel something something. Oh, okay. Let's go ahead and relog in or restarts required. I don't want to. I really don't want to restart. Okay. Anyways. So let's see. Web enumeration, net maps. Oh, maybe I need to run. I don't think I need to run this as sudo. Can't load this driver. I didn't have any problems with this before. Was I running it with sudo before? Or was I running it through wine? But yeah, the other choices I have is to switch over to another. Oh, okay. Sorry. Before we do that, we should probably just check out the application on the server. So on the server, it's running on port 9999, and it says welcome to vulnerable server, enter help for help. Great. Let's see, Oreobyte says this is when I started having a Windows dev virtual machine at the ready. You know, that's probably a good way to do it. What do we have here? So if we're doing a buffer overflow attack, we need to figure out which one of these user inputs is going to be vulnerable to the buffer overflow. So for example, if we do we've got all these commands we can run. So for example, if we run stats and then we give like a really long string, is that going to crash the program? The problem is that if we crash the program, then the program is going to be offline and then we can't interact with it anymore. So we should probably avoid crashing the program. Unless, well, okay. I guess it's okay to crash the program because we can restart the server. So, but in this case, we sent like a ton of input to the program. Let's see if we just send it like a bunch of stuff, if this crashes the program. So it still says status value normal, so this is probably not the place, not the point where we need to do the overflow. It's probably one of the other commands. So we got stats, we've got our time. And if we just do this, it says within limits. Okay, so we've got srun. We need to figure out which one of these values is going to give us our overflow. So we got R time, L time. We can test L time. Just give it a ton. High but okay. High but okay? Does that mean if we just give it even more stuff? What other values? What other things that can we feed to the program? We got srun. Complete. Whoops. Unknown command. Okay. Let's see. trun. So if we knew what exactly this program was supposed to be doing, like the intended gmon. So we're testing each one of these user inputs to see which one is going to lead to a crash. So we've tested almost all these commands. Huh, I think that one crashed the program. So that was KSTET, and that did it looks like it did crash the program. So if it actually crashed the program, we shouldn't be able to access the service anymore on port 999. Oh. Well, either that or it crashed the program and then it restarted the server. Okay, so what was that command again? The command was KSTET. So KSTET, feed it a bunch of stuff. Yeah. So it looks like this is the vulnerable command. So the next thing we need to do, man, I don't remember my workflow for Windows buffer overflow stuff anymore. Oreobite, hello, nice to see. Nice to see you here. Still bongoing around, great. Let's see. So if we just wanted to run this thing over here, maybe we could run it with wine. So wine vuln server. The wine configuration in this is being updated, okay. So this is vulnerable software. Do not allow access from untrusted systems or networks. Waiting for client connections. Okay, so this is the server software. I wonder if this is running on... Okay, so netstat. So this is running on local port 9999. Modish. Welcome to the HackerFrogs. Why don't you have a... Oh, how about we give you a nancat? There you go. Okay, so we've got the we have the server running on port 999 on our own here, so we could probably netcat localhost 9999 and blow it up. Okay, so so netcat localhost 9999. Welcome to vuln server. I wonder if we get any feedback here. So received a connection from localhost, this port right here, waiting for client connections. Let's do help. So I think this is the command that that let us crash the program. So let's test it with all of our input over here. The program has encountered a serious problem and needs to close. Okay, so it looks like we did crash the program. So yeah. Let's see. Turd Ferguson says, maybe we can pass bin sh as a payload with the variable. So this is a Windows server. This is a Windows server that we're dealing with. So we probably want to, well, okay, we're currently running it in Linux, but when we're dealing with the Windows version, with the Windows server, we should probably do command or like cmd.exe or something like that. So we should probably do our research. We can probably, yeah. Let's go ahead and run the Vuln server again. We do know that here's the problem. The problem is that this is running on a 32-bit version of Windows somewhere out there in the server. And, you know, somewhere out there on the remote server. It's a 32-bit version of Windows. It's server 2008 R2, and that's going to require. I don't know if we can use something like generic to compromise that particular version of Windows. Okay, so Motish says, thank you, awesome stream. I'm going to school for cybersecurity diploma in September. I want to learn right away. Yeah. So, well, I would start with a bunch of easier challenges. Motish, where have you been learning your cybersecurity stuff so far? Let me know. Maybe I can suggest some other places to learn about hacking stuff. Let us know what your previous experience is. Maybe I can suggest something. Okay, let's get rid of some of these files that we were working with earlier. So the other thing that we found on the server when we downloaded the Vuln server executable here is this essential function.dll file. I have no idea how we can take a look at what's inside this DLL. Maybe we can just run some strings on it first. We should probably run some strings on the Vuln server as well, just to make sure that there's nothing hiding there. So strings, essential function. Okay. So we got essential functions 1 to 14, great. We've got, it looks like a bunch of C stuff over here. We've got malloc and we've got string copy. We got printf. And we've got a bunch of assembly stuff. Called essential functions DLL version something something. Motish says, I'm familiar with Linux and have been using mostly TryHackMe and Hack the Box. I've only really done the introduction path since I'm not sure if they're going to be reliable for learning. When you say reliable, what do you mean? So Motish, you say that you're going to learn cybersecurity at school in September. Let us know what kind of cybersecurity role you're looking to work as in the future. Are you looking to do like penetration testing? Are you looking to do like web app security stuff? Are you looking to do network security stuff? Are you looking to do forensics? A very important thing about cybersecurity is figuring out which specialization you want to aim for, because if you try to learn everything about cybersecurity, it's going to be very, very, very slow, because there are too many specializations. So we got essential function stuff. We know that this is probably written in C, because we've got all these C function names over here. We should probably take a look at the strings inside of the Vuln server.exe file as well. Let's see. Jared Ferguson says, really like your approach, style, and commentary as you go through these. Thank you for doing this. Yeah, no problem. I mean, part of why I do it like this is so I can work it out myself. So if I'm talking out loud, then it's easier for me to organize my thoughts. So let's take a look at strings for the actual binary here. So I think this looks pretty similar. Motish says, I'm looking to do web app security as my primary goal. Oh wow, web app security, yeah. That sounds like a good That sounds like a pretty good specialization to aim for, because everything is a web application. And in fact, okay, well, I mean, this service we're looking at is not a web application, but most everything is a web application these days. Oreobyte says, since the application in computer is 32-bit, make sure that you use 32-bit shellcode or it will not run. Yeah, I don't know if we're going to actually finish this challenge today, because I'm gonna have to do a lot of research on how to do binary hacking against Windows machines. I haven't done it in a long time. Hypher256, hello, nice to see you here. That's a great avatar you have. That's the Black Mage from Final Fantasy. Awesome. Let's give you a fun little video redeem. How about the frog song? Welcome to the stream, Hypher. Hyper256 says, thanks, I said last night I jumped into chat. So you must have been one of the people that I was talking to last night. If you don't want to say who you were, then that's fine. Don't reveal any information you don't need to, but yeah. Bubblegum says, hey, good looking. You don't know what I look like. I'm pretty sure. But anyways, hello and welcome to the stream, Bubblegum. Thank you. Let's give you a, is this a hacking? Because when you type on the terminal, you're doing a hacking.
Is this a hacking?
Okay, so what do we need to... I sound charismatic. People tell me that I've got a pretty good voice for radio. I missed the era of radio by a little bit. Otherwise, I'd be working in radio. But, you know, we've got live streaming now. Okay, so we know how to crash the application. Essential function DLL version 1.0. Okay. Turd Ferguson's, I've got a good face for radio. I have the face for radio, of course. It's a good joke. It's a good joke. Okay, so we were running the strings, right? Where did we run the strings? Let's just run them here. Strings. So I'm pretty sure these strings aren't really going to give us any clue as to... Yeah. It's basically the same strings we saw in the previous DLL file. We can be pretty confident that this binary was compiled using... This binary was compiled from C language. KenPDX says video killed the radio star, and I was gonna say something about video. Anyways, ads on Twitch, so we do ads on YouTube as well. Let's go ahead and play my favorite video. My favorite video is these guys. These guys are my favorite bird video. We'll be back in about 30 minutes. We'll be back in about 30 seconds. Just have to take a little water break. Bubblegum asks, what are you looking for in the binary? So we're looking for clues in the binary. We know, well, we don't know for sure, but we heavily suspect that what we need to do to finish this challenge is to do a buffer overflow attack on the service that's running on the Windows server and get some sort of reverse shell connection. I don't quite remember how to create those, how to create that shellcode. KenPDX says, you don't see many cardinals lately. They're all off in Rome electing a pope. Wow, that's very topical, KenPDX. But Yeah, I don't see cardinals anyways because I live on the West Coast. Let's see. So if no port is provided, the default port of something 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 will be used. So 9999. Okay. So there are no real clues. Is a flock of cardinals called a conclave? Conclave. Maybe. Let's see. Let's search for this real quick. Group of cardinal birds. So a group of cardinal birds can be referred to as a college, a conclave, a deck, a radiance, or a Vatican. A Vatican of cardinals. That's pretty good. That's pretty good. But yeah, I don't have cardinals in my area. They are very, very beautiful birds. That is precious. Yeah. Anyways, so let's see. Do not access. Client connections. Failed with error something something. Okay. So... I did a lot of buffer overflows with Windows, maybe like 4 years ago when I was studying for OSCP, but I don't remember how to do the dang things anymore. But let me see if I can Google for something. Let's see, Windows buffer. How did you study for OSCP? I did all the lab machines on the OSCP network. So when you sign up for OSCP, they'll give you lab access, and inside the lab for OSCP, there are something like 100, maybe less than 100, maybe more than 100 now, because I haven't been there in many years. But there are a lot of different machines that you can access on the network, and you basically learn how to do hacking against each one of those machines. Each one of those machines is going to give you some experience with different types of networking configurations and different web apps and stuff. It's good practice. Aside from that, you can do a lot of boxes from Try Hack Me and from Hack the Box. That'll also give you good preparation for OSCP. Terry Ferguson says, curious if you looked in a hex editor and found the kstet string and looked to see what the context might be. Might not be a clue, but that's going pretty deep like a red herring. I have so much trouble following dead ends. Yeah, it's important that you don't stray too far down any rabbit holes. Yash says, can we prefer the books over the video courses? Can we prefer the books over the course videos? Are you talking about OSCP? The OSCP videos aren't... The ones that I saw were not super helpful. You're probably better off looking at YouTube walkthroughs if you're talking about quality of instruction. The thing about the OSCP videos is that they were published a long time ago. I don't know about the modern OSCP. The modern OSCP mostly has to do with Active Directory. And if you're studying for OSCP these days, then you probably want to do you probably want to do Active Directory challenges, and you can find a lot of Active Directory challenges on something like the Hackers Labs. They have quite a few. Yash says, in ethical hacking, I get bored seeing the videos. Feels like I don't learn anything. So most people who do cybersecurity and ethical hacking, they like to do a lot of hands-on stuff. So for example, over at the Hackers Labs, they've got a bunch of different Active Directory challenges here. And if you start hacking against those, you'll start getting a good feel for what kind of tools you need to do Active Directory Windows pen testing. Another good place to look is probably, would it be Vulnix? Vulnix.com. is probably another good resource. They've got a bunch of challenges for Windows. Not all of them are going to be... Oh no, it's not Volnix. It's probably hackmyvm.eu. So hackmyvm.eu, I think I can log in here, right? Yeah, I still have my credentials saved. So hackmyvm.eu is another one of these websites where you have to download virtual machines and then deploy them to your network. And they have a bunch of Active Directory machines. It's good for learning OSCP stuff, because a lot of OSCP these days is Active Directory based, because they've become they've become modern in their approach to pen testing, and modern pen testing involves a lot of Active Directory stuff. So there's this series over here that is going to teach you a lot about Active Directory. So this is the DC series. So they've got DC04, DC03, 02, and 01. I think 0 is another Active Directory box. And let's just provide the link for this to everybody in chat. Here you go. Hyper256 says, when did you realize you were ready to tackle the main exam? So, back then I wasn't ready to tackle the main exam because I didn't pass the main exam. But I felt more confident the more challenges you're able to do by yourself without looking at the walkthrough or the guide, the better and more confident you're going to feel about doing these kind of challenges in general. And basically, what the OSCP exam was in the past was like a gauntlet, like a series of five different computers that you needed to compromise in order to finish the exam. And only one of them, well, most of the time they didn't have Windows targets. Most of the targets were going to be Linux targets. But yeah, there are a few people here who have passed their OSCP exam, including people like OreoByte. So OreoByte has passed his OSCP exam. I'm pretty sure Sick in the Mind has to have passed OSCP because they're doing the more advanced versions. And there's probably some other people in chat who have passed their OSCP exam as well. Yeah, that's not much of a surprise. But yeah. So what do we need to figure out? We need to figure out the offset. Okay, so the binary buffer overflow stuff is all about figuring out the offset. The problem is that I can't use... I like using Radare 2, but I don't think I can use Radare 2 for a Windows binary. We could try manually figuring it out. Turd Ferguson says, I forgot to cancel mine. I had to take it during a road trip to... Oh, that's awful. That's awful. Had 5 hours or something to work on it. Yeah, that's gonna be brutal if you're dealing with all sorts of life stuff while you're doing the OSCP exam as well. So how can... What would be a sneaky... Okay, I could probably do this in like a sneaky way. The sneaky way would be to use like a try hack me machine and like transfer the file over there. But I'm pretty sure that's against the try hack me terms of service. So if I tried that, I would probably get my account banned. So, but it would be... I don't know. Yash says, I also have another problem that I often dig too much while learning and always feels like I'm missing something. In hacking, you need to know everything but not too deep. So how do you know when to stop? So here's the thing. When you work on these challenges, the ideal point to stop your research is when you know exactly enough to get your hack done. Of course, you know, if you want to dive deep into whatever topic is being, you know, showcased, like in, you know, if it's if you're dealing with IoT devices, or if you're dealing with Docker containers, you can get really deep into there. You need to figure out exactly the amount of information you need to get the job done, and then stop. It's tough. It's tough. Cypher Enigma says, I stop when it's 4 a.m. and the sun is coming up. Me too. Well, usually I fall asleep before that. But yeah. It's the OSCP exam, it's hard. It's hard for people, especially people who are new. If you're a person who's been doing this stuff for years, and you do OSCP, you might be okay. I might be okay doing OSCP now, but it's hard to say. Sick of the Mind says, there's no such thing as digging too deep. Always dig, but experience. It eventually becomes experience that you know that a particular version of a server doesn't mean anything fruitful for. Yeah, you have to learn how to read what is not vulnerable, or what is more likely not to be vulnerable. Because when you first start doing these challenges, you might take a look at like Nmap information, and you might get really overwhelmed by trying to figure out exactly what the heck is going on in each one of these ports, or like getting rabbit holed on services that don't matter. With experience, you'll determine like which ports you have to enumerate first, and which ones are probably not going to matter in the long run. But let's see. Let me see if I can. So, man, what debugger could we use? So, do we have like Windows debugger? Ah, jeez. WinDBG. Nope. X64. For some reason, X64 debugger broke somehow. Maybe because maybe we need to update our wind. So in that case, so sudo apt update. Update wind. Let's see, what do I want to do if I want to only update one package? Okay, so on Linux, what command do use to only update the wine program? So it's probably apt something something. Sudo apt update and sudo apt install only upgrade. Are we hallucinating here? I'm not sure if we're hallucinating or not. We can give this a try. Okay. Hold on. Well, we'll leave this alone for a little bit. So we need to get access to a debugger, because if there's no What, the yay flag. The yay flag is kind of hilarious. A little bit. Okay, did we actually finish? No, I don't think we did. Okay, so wine is already the newest version. The problem is, why does it say that it couldn't load kernel32.dll? Well, you know what? We've been asking the AI for other answers. How about this one? We are missing some library file on Kali Linux for wine. Okay, so wine is missing critical 32-bit libraries or incomplete installation. Okay, so we would do enable 32-bit architecture, update, install the thing. Solution 2 is to reinstall wine completely. Perform a clean install. Manually install kernel32.dll. Wine tree. I've never heard of this program. And let's create a little script. Let's see. Wine.sh. Nano that thing. Okay, chmod. Guess we should run that as sudo. Okay. I don't think it installed properly. So that means we need to test with a simple Windows app. So let's see, the error says that Wine couldn't load or find the 32-bit version of kernel32.dll. Always install Wine32 along with Wine on 64-bit systems. Let's see if we can find some DLL files. So we got DLL files. We're going to grep for kernel. I mean, kernel32 is here. Kernel32.dll is here. I don't know. I don't understand why it's not. Why Wine says it can't load the file. Okay, so maybe we really should be using some sort of Windows system instead of trying to brute force everything with Linux. In that case, maybe we could try using a try-hack-me machine. So let's see, try-hack-me. Don't break, you got this. Listen. We have to try a bunch of different stuff. There was a buffer overflow prep room, I think. Buffer overflow prep, right? Practice stack-based buffer overflows. Okay. So this is... I did this room a long time ago. And this room in Try Hack Me has a machine that we can use to test this stuff. So let's go ahead and let's try using the machine. So let's see. We need to log. We're not logged in. Try removing the wine directory and try again. I saw you install it from apt, so not likely the issue, but we can clear out the bad configure at the cache. Thank you very much for the suggestion, Turd Ferguson. We're gonna try using a Windows machine. So I'm gonna try just can we not log in? Oh, I'm not a robot. Where are the stairs? I don't know where the stairs are. Okay. I'm a robot. You got me. Okay, so let's join the room. And let's see if we can transfer this over. Let's see if we can transfer this thing over with the base64 encoding method. Depending on how large it is, of course. Okay, we got a minute to go. We're probably going to be... The C000135 error seems to have a ton of potential causes. Yeah, I'd prefer not to troubleshoot the thing for the next hour or so. We're just going to try using some alternative methods. Let's see. So you can log into the machine using RDP. Oh, okay. Looks like I'm going to have to connect using my OpenVPN key. I think I put it... Hold on. I think I put it in the root directory. Yeah, this one right here. So we're going to OpenVPN. We're going to log in to the Try Hack Me network. And then after that, we can use free RDP. I haven't used this program in years, but I guess we're gonna have to use it to log into the Windows box. Okay, so free RDP is a program you can use to log into Windows with a GUI, and it's okay. It's okay. The problem is it's not the best. Let's see. Admin password. Is this the correct IP address? Okay, so let's go ahead and try accessing the machine. Oh, I don't have it installed? Is it not installed, really? Huh. I thought it was installed by default. Maybe not. Okay, so let's... So it's called Free RDP 3. No? X11. Oh, here. Okay, yeah. I see it. I might have our desktop. So, I mean, I haven't used our desktop before. But thank you very much for bringing that to my attention. I have used FreeRDP before, so I guess when I've used something before, I usually try to stick to using that tool. Sometimes it's not the right thing to do. Sometimes I just, use something that I've used before for the okay, so let's hopefully I can use the command now. Huh. Do I need to restart some stuff? Well, I don't necessarily need to. Maybe I'll just use the if I use the attack box, it's gonna be man, this is getting more and more convoluted. Which X free RDP? This one is the command. The command is this. I'll just copy paste into chat. There you go. Okay, so this room uses a 32-bit Windows 7 VM with Immunity Debugger and PuTTY installed. Windows Firewall and Defender have been disabled to make... Okay. I left out the 3. Okay, we're in business. Or we're not in business. What's going on? So I've got some... I think the syntax might have changed between one version of FreeRDP and another. Unexpected keyword. So FreeRDP 3 file options /v server port. It's gonna be yeah, maybe if I have our desktop I can it might be easier. Anyways, let's our desktop. Okay, we have our desktop. What is the syntax? Our desktop. We got ads running on Twitch, so we run them on YouTube as well. Let's do... This is a great video. It showcases this spotted towhee bird. It is very nice. We'll be back in about a minute. Enjoy the bird and enjoy the music. Okay, so we've got some suggestions in here. Just give it to the IP as an argument, CanPDX, and Sick the Mind says probably just drop the TLS security level 0 instead of /TLS sec level. Okay, let's does the the bird doesn't come back. Okay, let's put the birds away. Change hyphen to colon. That's change hyphen to colon. That sounds, well, it does sound funky. So our desktop, the IP address. So I'm pretty sure we're connected. I need to make sure we have connectivity to the machine. Hold on. Let me get the IP address. That's the IP address. Let's try ping the dang thing. Oh, I don't think we have connectivity. In that case, we need to re-download the key. So let's see, access. Let's download the configuration file. Okay. And let's copy the thing over. Oh, it's in the downloads directory. Okay. So downloads. What do we have here? This. Actually, this is the most current. This is the most current one. Okay. Download that. Right. I guess we should rename this thing because it's very awkwardly named. And then let's run it. So it's going to be OpenVPN. Okay, so we should be connected now. Let's make sure. Looks like everything should be okay. Okay, we're connected now. So let's do our desktop, and we just need the IP address, right? So the IP address is... LightOS says, Ramina RDP client always worked well for me. Sudo apt-get install Ramina. I think I've worked with it before, but let's just see if our desktop works for us first, because I don't want to end up installing too many things. Do I trust this certificate? Sure I do. Sure I do. Why not? Okay, so it's gonna open up our desktop. Do we log in as ourselves, or as some... Well, let's just try logging in ourselves. What is our password supposed to be? Let's take a look at the information here. Let's try using... Maybe we should use the admin account instead. So switch user, other user, admin password. Okay, cool. Unfortunately, I don't know if we can make this nice and pretty. Oh, okay. It's not the prettiest looking desktop. It's fine. In this case, what we need to do is we need to move our binary over to this machine, and I guess we would use... This machine isn't internet connected, but we could try using the clipboard to move stuff over. Okay, so here's the trick. Hack Smarter has just rated the channel with 20 viewers. Thank you very much, Hack Smarter. And what were you doing on stream? I saw that you were streaming earlier. Let's do a shout out for Hack Smarter. Hack Smarter is another cybersecurity channel. They do a lot of stuff on YouTube as well. Let's shout them out. Hack Smarter, here you go. Hack Smarter says, I'm creating an intro to AWS pen testing course in creating the courses while I stream. That's a good use of your time. Get your work done on stream, and then you're killing two birds with one stone. That's awesome. But welcome everybody. My name is the Shy Hat. I do beginner cybersecurity content here on Twitch. I also do it on YouTube. We are simulcasting right now to Twitch and YouTube. If you want to check out my YouTube channel, I've got a bunch of beginner-friendly playlists over there. What level of room is this? So I'm trying to do some buffer overflow stuff for Windows, but since I'm working on a Linux system, I'm gonna have to use somebody else's Windows system to get this thing done. In this case, we're going to be doing something over on a TryHackMe machine. I just need to figure out how to move this file over. And I'm going to try to use the clipboard technique. So the clipboard technique is basically turning the contents of a binary file into base64 encoded strings. And this one, I don't think this file is particularly big, so we might be able to move it over using the clipboard. But then again, this does seem kind of big. Well, it's not super huge. Let's see if we can get this going. So what we do is we just use the clipboard to move this base64 encoded data around, and then we transform it into its original form after we paste it into another file. Signamai says, biting my tongue on Michael Scott commentary. Are you talking about The Office? Okay, so we've got our base64 encoded string. We're going to see if we can move this over to the machine here. I mean, the command line doesn't have basics. Actually, we should probably use PowerShell. I haven't used a lot of PowerShell in a really long time. But if we want to do some base64 encoding, we probably want to use PowerShell. So how would we do this? I should probably make this bigger. So I can make my font bigger. Yeah, okay. Thanks to AI, I'm the PowerShell Pro now. Okay, okay. Can we... Is there a text editor we can use? We could probably use Notepad or something. So let's just make a new text document, right? We'll call this vuln server. B64. Okay, and then we'll just open this up. We'll paste into here. Yeah, awesome, awesome, awesome. You might have SCP or wget or curl available. I think this will work okay if we can. Let's see. We're gonna save this out. I just need to figure out the PowerShell command. Actually, wait. I don't. This is the. This is the desktop, right? So it's cd desktop. And we've got the vuln server base64 over here. So it would be type vuln server base64 vuln. And then we would, so if we just do this, we get all up. Man, I feel like a hacker because I've got all this text flying around the screen. We need to pipe this out into base64 decode. So what is the command for base64 decode in PowerShell? Let's... base64 decode PowerShell. It's yeah, I guess so. Let's see. Klondike 7000 says looks good. Okay. Ken PDX, Pink Armor. Pink Armor says, did I miss something? Hack smarter, not harder. Wow. Thank you very much for following. EXPLOIT. That's an awesome. Okay, so encoded text. Declare the encoded string. How about from file? So get content, what is this command going to be? That's, man, it seems kind of long. It seems kind of long, but then again, this is PowerShell. It is kind of long. Get right. Cert decode. Oh, okay. So defis has the answer. You can use cert util instead. Okay. Sure. Let's try that instead. Cert util. Decode. Let's see. No. Ah, gosh, I forget the name of the file already. Okay, so cert util decode, and this is called vuln server b64 dot txt. We're going to call it, we'll just call it vuln dot exe. Okay, and let's take a look at. We got vuln.exe. This has a dependency. It's got the another file as a dependency called something .dll. So let's go ahead and find it. Where is it again? It's essentialfunctions.dll. So let's go ahead and do the same treatment here. So cat that thing, base64 encoded. Okay. Broken Aim, hello, nice to see you here on YouTube. Welcome, welcome, and why don't you have a Hack the Planet, because we haven't done one of those in a while. There you go.
Hack the planet! Hack the planet! Shut up,
So I hope this works. Okay, so copy. Man, this one's pretty big too. Anyways, copy that to the clipboard. Then let's make another file here. We'll call this one what was the name of that file again? It's called essfunc, essfunc.dll. Okay, we've moved it over, pasted in the stuff. I feel like a hacker when when all this text appears on the screen and scrolls by. This is when I feel like a hacker. Anyways, save the file, and we're going to decode it using using PowerShell again. No, sorry, cert util. So this one's going to be called essfunc.dll, and we're going to decode it from essfunc.b64. Okay, cool. Gralton123, let me get that for you. Why don't you need to correct the spelling on the word redeem there. I think Hack the Planet might be on cooldown. You could try Nyancat instead. But yeah, wow, we've got quite a few people watching right now. Jeez, all this pressure on me. Anyways, we're trying to figure out if we can do some buffer overflow for this Windows machine we're looking at today. I should probably update the termination time on this machine. I guess I can't do that right now. That's fine. Thank you very much for Broken Aim. Broken Aim, thank you very much for the subscription on YouTube. Why don't I give you a... What haven't we done in a while? Hey, does anybody know this this particular show?
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
Okay, sometimes the servers have more firewalls than the devil's bedroom. Who knew? Thank you very much. Thank you very much for the Hack the Planet, Rolton123. Thank you very much. So we got essentialfunction.dll, we've got vuln server, vuln.exe basically, and this is the server we need to to take a look at. Okay, let's run vuln.exe. The command oh, we need to do this directory, vuln.exe. Okay, so yeah, it's running. Okay, cool. Grolden123 says, "What is your Twitch?" The Twitch is the same name as the YouTube. It's the Shy Hat. So if you search for the Shy Hat, you'll see the Twitch channel. I guess I can grab the Twitch channel for you just for twitch.tv, the Shy Hat. Yeah. So if you want to look me up on Twitch, there you go. Okay, so what do we need to do? We need to run this thing with immunity debugger, I think. So first of all, we probably need to shut down this thing. What do we do from here? Task manager? Where's the task manager? Or do we do task manager with Control Alt? Does anybody remember what the name of the application for Task Manager is? Oh, okay. Sorry. Maybe we don't need it. I managed to get out of the program. Okay, so what do we need to do? We need to run immunity debugger, right? I haven't used this program in so many years. Okay, so we're gonna... It's attach, right? We attach a program, and I've forgotten, yeah, so I've forgotten how to use this program, jeez. So attach, select process to attach. Do we need to run it first and then attach? Okay, so that means we need to run vuln.exe and then attach. Yeah, okay. Run it, then attach it. Sorry, you shouldn't be running two instances of this thing at the same time. So we're going to attach... It's called vuln, I'm pretty sure. Oh man, I can't read this stuff worth crap. It's so small. I wonder if there's a way to make this stuff all bigger. Grolden123 asks, what are you doing right now? So we're trying to figure out how to do a buffer overflow attack on a particular Windows binary. Problem is, I haven't hacked Windows binaries in a really long time. So let's see. Appearance, fonts. Okay, I think I can make these fonts bigger because, man, the current font sizes are killing my eyes. So we can change the font. We need to change the size. Man. Paperland says, great to see this live. Control Plus, I think. Don't trust me. Control Plus. I don't know. Well, I mean, that works with web applications. I don't know if it's going to work with this application in particular. Because trying to look at this, even like I have access to the actual screen, this still hurts. Color scheme, default font, dialogue. Grolden says, are you trying to reverse it? Watching, understand nothing. Okay, so we have a beginners playlist. If you're new to cybersecurity and you want to learn about some basics about how to get into cybersecurity and all that other good stuff, we have a playlist that uses Pico CTF, and Pico CTF is a great little platform for learning about cybersecurity stuff. The playlist is over here, and if you work through the playlist, it'll teach you about a lot of fundamentals for interacting with Linux, and then how to take a look at how to work with files, how to do like basic web application challenges. It'll run through a bunch of different topics, stuff like Python, stuff like web applications. Work through the playlist, and you'll start accumulating a bunch of little tricks that you can use to take a look at all sorts of different software and different programming languages. It's pretty accessible. It's not too difficult, especially the first maybe 10 or 20 videos. They're all very beginner friendly, but eventually they become more difficult. But you'll need an account over at Pico CTF to work through these challenges. So the link for Pico CTF is just over here. There you go. But yeah, as far as this is concerned, we need to make this font bigger. Otherwise, I'm not going to be able to make it through this. Let me see if I can search for something. Immunity debugger. Let's see. Pico CTF. Yes, Pico CTF is free. No worries. No worries. I understand everybody's on a budget. It's hard to pay for stuff, especially if you don't know if you're super into it or not. Immunity debugger. Font size increase, please. How to change debugger font size. So IDE files. Let me try playing around with this a little more. Okay, file, view, debug, plugins, options. It has to be options appearance, right? Code highlighting, colors, fonts. We don't have very many choices. We only have font 7 and font 6. These don't make a lot of difference. The only other thing I could do is I could just try to work through this as quick as possible so we don't have to stare at this tiny font for the rest of the stream. But if anybody knows if anybody knows how to make this stuff bigger in Immunity Debugger, let us know. Let's see, directories, dialogues. So there was a certain technique that we used to inside of Immunity Debugger to detect a pattern. I'm pretty sure. Ah, we got our registers up here. I can't even read the dang thing. Oh wait. Huh. Can we? This is a little bit easier to read. That's the AI. What font are we using? So this is Courier Unicode. Okay, let's see if we can change it all to Courier Unicode. This is a little bit easier to read. Yeah, okay. Alright, so what do we need to do? We need to figure out what the, what was Mona, right? The name of the Python plugin? So, let's see. Mona Py pattern create. I used to be able to do this stuff in my sleep. That was like 4 years ago, though. Okay, maybe we need to ask the AI, because I'd rather do this faster than slower. Using Immunity Debugger and we are trying to... Neems asks, what is this? So we're using a Windows debugger program because we're dealing with a Windows buffer overflow problem. So we're working inside of this TryHackMe room over here, and we're trying to figure out how to do the buffer overflow on this particular Windows binary over here that's running on the server in our challenge. To determine buffer overflow offset, what commands do we need to use? I guess we could also take a look at the write-ups for this particular TryHackMe room. Okay, we got ads running on Twitch. When ads run on Twitch, we also run them on YouTube. And let's go ahead and do a fun bird video. How about this fun bird video? Here you go. Okay, we're just going to take a minute to have a little water break. We'll be back in just a second. Please enjoy the birds and the music. And enjoy the moody music. Yeah. These birds sure do love their peanuts. They just stuff their faces. Man.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
Thank you very much for the redeem, Grolden123. Devil's bedroom indeed. Anyways, yeah, this guy stuffs his face. Let's put the birds away. And I think what we need to do is we need to take a look at a walkthrough for the TryHackMe room. It'll teach us how to do the workflow for Immunity Debugger, because I need to learn how to do that again. So buffer overflow prep from TryHackMe, and it doesn't matter which one of these. We just need to know the exact steps. The devil accidentally included me in his group chat. Are you talking about the U.S. government and their signal stuff? Anyways, Neem says you actually made me at these. You actually made me laugh when he said these birds sure do like their nut. Well, you know, well that's true. It's true. They do love their nuts. Anyways, let's take a look at any one of these random write-ups here. I just need to figure out. He wrote a. Okay. Navigate to the file, then debug run. Sure. Mona configuration. So Mona config. We need to set this up inside of Immunity Debugger. So the working configuration is going to be cmona something something. I'm pretty sure we can use the very same command here. We have to run this inside of Immunity here and paste in the command, run it. Okay. The next thing we need to do is what? Create the script on the attacking machine. Do we? I mean, I don't know if I don't necessarily think we need to use this Python script in particular. We'll come back to it later if we really need to. Okay, so crash replication and controlling the EIP. Use cyclic. Right, this is the program we use to create our cyclic pattern to try to figure out the offset for the buffer overflow. So use cyclic to create a cyclic pattern 400 bytes longer than the length of bytes that crash the server. 400 bytes longer. We don't know exactly how many bytes we need to crash this server, so I guess we could try 400 to see if it crashes the server. So in this case, we would do this command inside of the debugger. It's going to be cyclic, let's do 400. Huh. Wait. Oh no, okay. This is this is probably going to be on Kali Linux. No? Okay, so we don't necessarily need to use cyclic. We could use something like rag2 instead. Let's do rag2. We'll give it 400. Let's see. Hoi Minoi says it's impossible to read this watching. It's too bad. Yeah. If I need to find some way, this stuff in particular, I can't make this. I really want to make this bigger. So let's just try. This makes it a little better, but it's still hard to read. Can I make it larger? How about Lucida? No, that's smaller. But anyways, I'll change it back to the courier over here. We need to make our cyclic pattern, so we could just use this instead. Rag2, it's fine. I'm gonna try to do this as quick as possible, so we don't have to stare at this tiny font. Anyways, we'll use this, and I guess. So we need to give this command. The command is kstat, I think. Kstat space. So kstat space is how many characters? Hold on. So kstat something like this. So that's how many characters? 1, 2, 3, 4, 5, 6. So this is 6 characters, so we just need to delete 6 characters from here. 1, 2, 3, 4, 5, 6. We need to give kstat space. And this is the command we're going to be feeding to the binary here. Go over to... Okay, so we run the program. Now how do we feed input to the program now? Yeah, BinX, Hacker Ted. Hello, nice to see you here. Jeez, let's give you a Nyan Cat, Hacker Ted, because you got a cat. You have a cat avatar. Okay, restart the thing. And what's on Monday's schedule? Monday's schedule, we're going to be starting our digital forensics. So we're going to do digital forensics, and we're going to be taking a look at picture files. I'm going to be doing that as part of a course I'm doing with a kids program. So where I'm not going to be paying a lot of attention during the program because I need to pay attention to helping the kids learn about digital forensics. Okay, so immunity debugger. We need to learn how to provide input. Adding input. It has to get an input data file. How to debug an exe with input parameters. How to see all items. So you just do redeem. Yeah, redeem. It's exclamation point redeem and then item. So redeem space. We've got SJ no flicker is this hack the planet. All this good stuff. Step into, step over. Okay, maybe the AI knows. Okay, using Immunity Debugger. How do we provide user input? Linux? I don't think we have a Linux one. But any of the ones you see in the Restream bot over there. You don't need... Nobody actually needs HackerBytes right now to redeem anything. You can redeem things as much as you want. Okay, what did it do here? Okay, so generate a cyclic pattern. What is it? Oh no. Okay. Okay, send input via network socket. Okay. So this, I guess we do need to use some sort of Python script. So send input from another terminal. Use a Python script or netcat to send payloads. Okay, command line arguments. Launch the binary with arguments. So I guess we'll use... So there's no frog. There's no frog redeem. There's a frog song redeem if you want to use frog song. Okay, so the service should be running, and we should be able to access it from. Okay, I'm starting to remember how to run this thing. So let's see, what is the IP address for this machine on Try Hack Me? So the machine is located at this IP address. Let's try to reach out to it. First of all, we should probably nmap the thing. So nmap this thing. Port 9999. Okay, so it says it's closed. We need to...
What are you?
I'm system root.
Thank you very much, Grolton123, for redeeming I'm root. We're not root yet. Maybe in an hour or two. Who knows? But we got, what do we got on remote machine? Let's go ahead. It's paused execution. We need to start running the server. Run program. Okay, so that the server should be running now. Let's go ahead and scan it with nmap. So the service is open now. Let's go ahead and give our malicious payload. So this is the malicious payload here. So I guess we'll use netcat. Why do I always say thank you? I always say thank you because, you know, it's better to say thank you than to not to say thank you. Not saying thank you is rude. Alright, let's... Okay, so I think I crashed the program with this command here. So we sent the kset command with a bunch of random stuff. Golden says I could say nothing. Well, I'd rather be polite than to say nothing. But anyways, let's take a look and see what happened in the application here. It looks like, is it still running? It didn't crash. Okay, so it looks like... Okay, let's run netcat to interface with the server. Then we'll send this. We'll see what happens. Okay, we're not getting any... Did it crash? Okay, it looks like it crashed. So let's take a look at the values of the registers. So the IP... Oh, this is so difficult to look at. Let's copy this. Okay, so we managed to successfully get it to crash, and we probably have... We can probably get an offset. So this is what we found in the EIP register after the crash occurred. So it's 41... What is it? 41614141. 41614141. So 41s are A's. So it would be 0x this thing. Rag 2 So this is 76 bytes. So if we're trying to form some sort of payload, it would be 76 bytes. So we can try doing this with Perl. We were doing this earlier today. So Perl, let's see. Perl A, we can send a bunch of... What do we need to send? We need to send the word kstat as well. So print kstat space. So kstat space, this is one thing we send, and then we can add something else to it. We could add a bunch of A's. A times how many? So 70, so kstat space is, oh sorry, I have to spell this correctly. So kstat space, 1, 2, this is 6. 1, 2, 3, 4, 5, 6. So 76 minus 6, 70. So we send 70 A's. And then let's send a bunch of B's. So we'll send B times 4. So if this is correct, if this is the correct offset, then we should see 4 B's in the EIP after it crashes. So we need to reset the binary here. Restart. And then run. Okay, so we restarted the thing. It's running again. We're gonna go to here. We're gonna run this Perl command. I guess another thing that we need to do is we need to send the enter the new line as well with this. What is the hex code for new line? So new line is hex. New line hex. New line hex code. It's 0A something, right? 0A? 0A. Okay, so let's see what happens when we send this through netcat. Port 9999. Okay, so I'm pretty sure it crashed. Let's confirm. No, it didn't crash. Huh. Didn't crash. Let's try. Okay, well, what else can we do? We can just send a bunch more stuff. Let's send, I don't know. How about A times, send another 200 A's, or 100 A's. So just to make sure that that Perl is actually doing what it's supposed to be doing, just gonna, yeah, so this does send a bunch of A's and a bunch of B's. Just need to didn't crash. Okay, so just to make sure that this is working, let's just connect to the machine first. So that wasn't enough. That wasn't enough to crash the server. That still wasn't enough to crash the server. Still not enough. Something tells me that it's weird.
This one's dedicated to all the hackers. Yo.
Defus, thanks for redeeming the all the things redeem. It's a great hacker anthem. Drink all the booze and hack all the things. Okay, let's man. Let's try that one more time. Oops. What was that payload that we sent that one time? This one. This was the one request that we sent. And it was AA... 400, huh? Okay, 1, 2, 3, 4, 5, 6. Okay, let's do this one more time just to make sure that it wasn't some sort of fluke that last time. Then send this thing. Huh. It didn't. Why is this stuff not crashing? Hold on. Let's restart the thing. Restart. Run. Okay. Go back. That didn't crash the server. That didn't crash the server. Okay, let's make sure that the server's up, right? Let's reset, restart the service. Run the server. Okay, then we netcat in. We get some help. kstat. Kstat, right? That's the thing we need to overflow. Paste this in. That crashes it. So this is crashed. So 41, 61, 41, 41. 41, 61. Which one is... One more time, I'm going to copy this value. Then I'm going to figure out what the offset is supposed to be. I don't think the overflow managed to get into any of the other. So 61 is small a. Yeah. Okay. So where is the pattern in here? So it's AA small a. AA small a. So it should be this. This should be the pattern in here. AA small a AA. We don't need this anymore. Six one 4161 4141 4141. So it's a four character pattern, and it should be this portion right here, right? So when we scan against that pattern using the tool, so rag2 q sorry, there. So this is in hex. This is in hex. This should be big endian. So use the same pattern, replace the bit you think it is with something else like 333. That's some good advice. So let's get this pattern. So 333, like, which is 30 30 30 in hex. Yeah, no problem, no problem. Okay. So the pattern, I think it's going to be right here. Where is it? Where's that small a? There it is. So it should be this. 1 2 3 4 1 2 3 4. Okay, we got ads running on Twitch. When ads run on Twitch, we also run them on YouTube. There you go. And let's do the bird that... How about the happy birds? These are the happy birds right here. They're birds that are okay with eating from the same bowl. Anyways, we'll be back in about 30 seconds. Just gonna have a little water break. Oh my god, it's almost 9 o'clock. I need to get off. I need to get off pretty soon. You know what? I'll get off after I confirm the offset. How about that? Okay. So, jeez, this is really late. I don't usually don't stream this late. Let's put the birds away. I really want to confirm this offset first. Okay, so this is the pattern. We're going to do our desktop. We're going to reset the server. Then we're going to play the thing again. Okay. So let's go ahead and try to confirm that offset. So over here. Okay. Connected to the server. Paste the clipboard. Am I in California? I'm not in California. I'm on the West Coast. Not California. A bit north of that. I'm not human. I'm not human anymore. I've turned into a hacker. Hackers aren't human. Okay, so for some reason that we need to do something first before we submit the actual payload. Otherwise, it doesn't work. So that's kind of funky. Let's do. I'm in the Couve. I'm in Vancouver. Yeah, the Couve. I won't tell you all exactly where I am in Vancouver, but okay. So that still isn't a crash, huh? This is supposed to be. This input should cause a crash. I'm not too sure what the heck is going on. Help. Help. Bam. Portland. Oh, okay. Did you, there are a bunch of cybersecurity conferences going on in the next couple of weeks. There's like, B-Sides San Francisco, and there's B-Sides Seattle. So are you, do you go to any of those conventions? Kind of like everybody in Toronto calls it Toronto. Nobody calls it the Couve. Nobody calls Vancouver the Couve. It's not, that's not a thing. Okay, let's try... Huh. Yeah, I don't know why. What exactly is going on with this. With this. Oh, Portlanders call Vancouver, Washington the Couve. That's interesting. Yeah, for some reason is the debugger attached to the right process? Well, we've only been using the one process. Okay, so restart the thing. Run the thing again. We've been using the same thing. Thank you very much for following. Too Big to Flail. Too Big to Flail. Awesome name. Awesome name. Let's give you a Hack the Planet. There you go.
Hack the planet! Hack the planet!
Okay, so the thing is running. Let's try... So what was the process? So I scanned the thing with Nmap, and then I accessed it with Netcat. I got the help menu, and then I sent the payload. Okay, so we did actually crash the program this time. It's weird. It is really weird. So it looks like, yeah. So the we almost controlled the AIP, except there's an extra A in here. So I think we need to adjust our payload just a little bit. But you know what? I think I managed to get the payload. I want to get the payload exact. So I'm just gonna adjust it a little bit. We need to put the extra 3 in here. And I wonder how long the string actually needs to be in this case. Ken PDX says there's a funny skit on YouTube about a British tourist trying to visit Vancouver, BC, and he ends up in Vancouver, Washington instead. Not that I'm not trying to say that there's nothing cool in Vancouver, Washington. It's just that if you're expecting one but you get the other, it might be a bit jarring. Okay. I'm not pulling a 24-hour. I'm going to find out exactly what the... I'll say it then. Well, okay. Alright, let's try to recreate this crash. So, we need to figure out exactly where this is in the... in the application after it crashes. So we're going to restart. So here's the thing, for some reason if I do these exact steps here, it'll crash. So the steps are scan the port with Nmap, and then access it with netcat, get the help menu, and then paste in the payload and send it. This crashes the program. When we go over to the application, we see that the EIP has been completely overwritten with the threes that we sent in there. So 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. So that means that the offset is this many characters, and this many characters we're gonna figure it out by doing. So echo this thing, type it out to word count. This is 80 characters. Huh. That's funny. Okay, so I'm satisfied. I'm satisfied so far. I managed to use Immunity Debugger, which I haven't used in like 4 years, and I was able to get an offset at least. Maybe I can come back to this challenge next week, and we'll try to finish it off, because I certainly spent enough time researching on this stream. But let's see if there's anybody cool streaming on InfoSec streams right now. There's Kirasek. Hey, Kirasek is another cybersecurity content creator. And let's pay it forward. I got a lot of raids today, so I'd be happy to pay it forward and give some viewers to Kirasek, who is doing what? Kirasek is doing Hack the Box in Home Lab, day 135. Everybody, when you arrive on Kirasek's channel, if you could give this raid message here: OS Frog, Hip Hop Hack, OS Frog. Just like this, I would really appreciate it. Okay, but we'll be back on Monday. We're going to be starting our digital forensics class on Monday, and what else? Everybody have a great weekend, and I appreciate all of the people who came by to chat. Lots of new faces, as well as a lot of old ones as well. Let's raid Kirasek. All right, everybody. Have a great hacking weekend, and we'll see you on Monday. 3, 2, 1, HackerFrogs out.